Yeah, hello everyone. Good morning, good afternoon, good noon. We welcome you all at Global Conference by AWS User Group Jaipur, Rajasthan, OSTech Conf 2021. We are so happy to have you here. As the name suggests, OSTech Conf. So it's not mean like we are only focusing on AWS or AWS services kind of things. Okay, so now we are coming with a broader level of technology. So the name suggests OSTech means open source technology. So it can be anything like DevOps, cloud native, software development. It can be anything where you have interest in. Okay, so you will be finding sessions in our this conference in upcoming 2 days. Okay, so there will be lots of session today also and tomorrow also. If you need any of the information, just check on our website. It's all here. If you have any doubts about quizzes, live contests, okay, or knowledge share contests, so just check on our website. It's all there. Okay. So I think we are good to go, and I have one quote to just motivate you all. Like, so the best preparation for tomorrow is doing your best today. Okay, so with this, we are starting our conference, and let me introduce our team. So I am Aditya Soni. I'm working at Red Hat as OpenShift Technical Support Engineer, and we have we are three organizers. So over to you, Seema.
Hello everyone, I am Seema Saran, currently working as an application developer at IBM, and I'm so excited to have you all here. And yes, enjoy this conference. And yeah, over to you, Bineet.
Hello everyone. Thank you so much for joining in. So my name is Abhineet and I am working as a cloud support associate in Amazon. So yeah, excited to look forward for you all guys for the event and happy learning guys.
Yeah, so let's start with our so what the agenda we have for you all. So yeah, so can you please move to next slide? Yeah, so thank you all for your overwhelming response. Okay, so for this conference, we got 20K registrations. Okay, and in just 3 weeks. Okay, so and you can check. This is like you all are there, so you must be knowing. Okay, so the reach of it, and now we are having the family of 2,500 of people in our community. Okay, it's growing, so it's kind of 2,500 plus. But yeah, yeah. Next. Yeah, so if I say about our team, so we are the three organizers. So me, Aditya, second is Seema, then Abhineet, and we have our route heroes. So these are the people who are just coordinating with us and helping us to get the event done and to add the best practices. Yeah. So if we, yeah, over to you, Seema.
Okay, so today we have a great line of speakers. So the keynote will be started by Ricardo, and following up with that, we have Prateek Narang from Google, and Michael Frederick from GitLab, Bill, that will be happening tomorrow. And there are so many great speakers in this conference. Yeah, next slide. So this conference wouldn't be possible without the support from our sponsors. So thank you, Red Hat, Reskill, CNCF, Daily.Dev, GitHub, Davetron, MapMyIndia, Skillship, Sticker Mule, Coding Blocks, Docker Jaipur, and Agora. Also, thanks to our community partners for supporting us throughout this conference and making it a huge success for us.
Yeah, so let comes to the part where you all must be excited, and I have checked the comment section. So I got a lots of comments over this. So yeah, we have like in the past some days we are having this contest that was live. Okay, but then we have just closed this because as we mentioned in guidelines, like we will be having 200. The first user will be getting the first 200 user will be getting some goodies or specs from us. But that deadline exceed, and that's why we actually closed that particular thing. Okay, but still if you have submitted the link or the form, then we will be reaching out to you after 25. Okay, so there is no need of asking this again and again, what is about like we have done this particular contest or something. So this answers your question, I think. And yeah, So yeah, so now that is thing done. But now also we are having two live contests in this particular conference, I can say. So there will be live quizzes. Okay, so after each session, we will be having live quizzes for you. Okay, so you don't have to go anywhere. Just don't track on Slack or something like where you will get the links. You will find the link in comment section itself. Okay, so let's say if one section ends, so you have to join that link, and there will be one quiz we have planned for you, and you have to just participate in that. Just keep in mind, check the guidelines of website if you have any queries, okay, for the quizzes. Okay, and there's a knowledge share context. So what do you mean by knowledge share? So let's say you are attending the particular conference or session, and you are having like you are learning something. Then what you have to do, you have to just take a screenshot, just post it on your social media, LinkedIn or Twitter. Okay, just post it out there. If you and we have given you the form link. Okay, so in the form link, we have already given there one link. Okay, you can submit multiple links there if you are posting at the multiple platform, and tag us and tag the speaker from which you are learning and what you have learned. So the content summary must be there for getting eligibility, and top 20 winners will get some awesome swags that you can check on, I think, website itself. Yeah, so this is another ambassador scoreboard. So I'm showing this because this is also the program ends, and we are having these top 10 ambassadors from our past, I can say, past 2 or 3 weeks. Okay, so these are the people who just helped us a lot to get some good reach in our program, and lots of things are there. So yeah, this is the program closed, and this is the final list. So if you have queries like I am in the ambassador program, what's done with me? So this is the final list, and we will be reaching out to you after 25 with this list also. Over to you, Sima.
Yeah. Okay, so the wait is finally over, and we have a great keynote speaker with us. Let me introduce him. Yeah. Okay. So Ricardo is an enterprise evangelist at Amazon Web Services. He works with enterprise executives and technology leaders to help them adopt the cloud and transform their businesses. He has over 20 years of experience leading emerging technology and innovation programs, and he has been working with cloud technology since 2008. So he is quite experienced, and he is literally a great speaker, and he is passionate about cloud innovation and open source, and is excited about how cloud accelerates and amplifies customers' ability to innovate. So over to you, Ricardo. Yeah.
Hello, and a very warm welcome from wherever you are joining us today to OSTech 2021, a two-day event for builders who want to gain insight and knowledge of the latest cloud-native and open source technologies. My name is Ricardo Suarez. I'm a principal developer advocate for open source, and I'm delighted to kick things off today by talking about two of my most favorite things, open source and cloud. Now, I am been working with open source for over 20 years, and I want to share some of the things that I've learned in that time, helping builders as well as businesses to develop better software and get better outcomes through open source. But first, I want to talk a little bit about what actually is open source and why does it matter. Now, open source is over 20 years old, but the concepts behind it and behind open source actually go further back. Now, there's a long history of legal and commercial activities that led to the creation of the Free Software Foundation in 1984. This in turn led to the creation of the Open Source Initiative in 1998. Now, open source was a shift away from the Free Software Foundation to a more commercial and business-friendly way of applying the same principles. They are similar, but they're not the same. The Free Software Foundation used the 4 freedoms as its litmus test as to what free software should look like, which is what you can see on the left-hand side here. The OSI created the open source definition, or OSD for short, and is a set of 10 requirements a license must meet to qualify as open source. And this is the list on the right-hand side here. Now, the open source definition, the OSD, is the fundamental component of what makes something open source. And today, there are over 80 licenses that meet the OSD requirement, are therefore open source licenses. But when we look at what open source is today, it's really two things. The first thing is it's emerged as a way of helping to reduce the friction for developers by providing them a mechanism that allows them to easily license the software that they create under terms that follow those open source principles. And it allows someone consuming the software to understand how they can use it. And that standard definition and framework for licensing makes it easy for everyone to understand what they can and cannot do and what their obligations are. Now, the second thing is that the way software is built and collaboratively developed, the supporting tools, the governance models, as well as the emergent frameworks and methodologies that support this is the second thing of what open source is today. But where is open source heading and what does the future hold? Now, before I answer this, I'm going to come back to this later. But first, I want to talk a little bit about why builders love open source. Now, as a future or current builder, you might be asking yourself, why should I take notice of open source? It turns out there are many reasons why developers love open source. And I'm not going to cover all of the ones here, but let me just look at a few of them. Now, for some, it might be having the freedom and space to experiment with new ideas. For others, it might be scratching the itch that's been the seed of many new open source projects. Or it could be that you want to engage with open source projects that provide you with a much more broad range of and exposure to ideas and technologies than you normally would have access to. Open source gives developers a way to express their creativity whilst they're doing their work, and it eliminates obstacles as well as improving their productivity. Now, in his study of working professionals, author Daniel Pink wrote in this book, which is a fantastic book, I highly recommend this book, that among kind of a group of people he studied, specifically open source developers, one of the key motivations when working in open source was that it allowed that group of developers to work at their peak, experiencing what he termed flow. Now, flow is a combination of these three things: the ability to have a purpose in the work you're doing, the ability to work towards mastery and expertise, as well as being able to do that under terms that you are in control of and have autonomy over. And when working in open source projects, what he found was these developers were able to achieve these three things and work towards flow. Now, open source produces unique opportunities for developers to gain new skills, to gain experience on technologies that power millions of applications that businesses depend upon, and can help you build a reputation and recognition amongst your peers. Now, according to this Linux Foundation survey back in 2019, 62% of the developers said they would be more successful if they could allocate paid work time to contribute to open source projects. So it's clear that developers recognize the value of participation and contributions to open source projects. Developers themselves have also spoken and said that they are most successful when engaging in open source development, and that this has had a significant impact on the success that they've had in their careers. Now, I try and do surveys and get data points from time to time. And when I did a survey as to why builders like to contribute to projects, it was no surprise to see that one of the key motivations is that they want to contribute to projects they use to make them better. But it's also interesting to see and read other surveys as well that show that builders love to contribute to open source projects for a number of different reasons, both technical and non-technical. In fact, that increase of soft skills is really important as you want to collaborate with others, both in open source or in your commercial day-to-day work, and will help you be successful within your career. Now, it's equally important that open source is loved by businesses as well. And when we see why, it's because increasingly open source has become strategically important. And there are a number of reasons for this, but let's look at a few of them now. The first is that whether you realize it or not, you are consuming open source software. This was a recent report from Black Duck, who audited code from enterprises and found that 96% of that code contained open source components. Now, I've seen more recent reports from Black Duck, Synopsys, and Red Hat that all point to similar figures, or in fact higher, and they all point to the fact that you cannot escape open source. Combined with that, software is at the center of digital transformation, with many enterprises now growing their technical competencies as well as resources. There was a recent article I was reading a few weeks ago on Forbes that explored how developers and software are fueling the next trillion-dollar enterprises, and explored how businesses such as Capital One are driving business value through software. Now, of course, if you want to be good at software, you have to be good at open source. And according to a recent report from Forrester Consulting, 95% of those companies that were surveyed who possessed a good open source strategy either met or exceeded their business expectations. So open source increases innovation by accelerating the adoption of in three ways: by adopting the emerging technologies, by lowering the cost of experimentation, as well as removing undifferentiated heavy lifting. Now, many emerging technologies initially start off as open source projects, from machine learning to data to Internet of Things. And these emerging open source projects make it easy to explore those new areas of technology at very low cost. Open source lowers the cost of experimentation, as you can simply download the software, providing builders with a really easy and quick way to try, explore, experiment without having to pay any software licenses. And open source projects contain the building blocks on which you can use to build your own products and services. And these are critical when you're looking to accelerate innovation activities such as prototyping. Could you imagine, for example, today trying to build a new prototype without your favorite open source building blocks? According to a recent McKinsey report, businesses reported 30% more innovation when you were using those open source components. Now, I like to spend time speaking to builders about open source and asking them why they have embraced open source. And last year, I was lucky enough to speak to the co-founder of AppSmith, which is an innovative low-code open source application. You can listen to the whole interview to get a deeper understanding of some of the reasons why open source made sense for his business. And here are just a couple of the things that he mentioned in that interview. So back to the future of open source. As builders and businesses grow in their use of and adoption of open source technologies, one of the challenges that I began to see many years ago was the more time spent managing the running and operations of open source, as well as seeing challenges in the support of the increasing number of those open source technologies they want to use. And the conversation quickly turned from, I want to run this open source technology, to I want someone else to run it and operate it for me so I can focus and concentrate on using and getting the benefit of that open source technology. And this is where cloud enters the story. At AWS, we strongly believe that the operation of great open source software is as important as the software itself, because managing that software as a service for customers makes it accessible to a much broader population. And this enables cloud to act as a force multiplier for open source technologies. And it does this in ways such as validating and raising the visibility and awareness of those open source projects and technologies to a much, much bigger audience. Cloud provides customers with the flexibility of running open source projects, or making it easy for customers to use and consume those open source projects, either through things such as the AWS Marketplace or through managed services for which open source projects they love and use. For example, AWS offers managed services through many open source technologies such as Apache Airflow, Hadoop, Kubernetes, and many, many more. So as a company, Amazon is customer obsessed, and many of our customers are enthusiastic users and creators of open source software, but also Amazon itself is an organization of builders, many of whom are also users and contributors to open source software. And this influences how we think about open source software, and we aim to build relationships with open source technologies and projects that will outlast any single one of us. Now, innovating on behalf of customers is part of the Amazon DNA, and we continue to innovate with open source. And we'll see in a bit some of the projects, but we've released more recently projects such as Bottle Rocket, Firecracker, and Babelfish, and many more. Now, when AWS launched back in 2016, it's hard to imagine how cloud could have existed without open source. And like many organizations, open source is a key enabler for Amazon. Being true to our customers means being true to open source, and we strive not to be just good citizens, but also to be good leaders in open source. And we advocate for and partner with our customers in using, growing, and innovating with open source. Our participation in and support of those open source projects encompasses our own project code and contributions, as well as code contributions to other projects, but also includes things like financial support of open source foundations and projects, events that we sponsor, and many more. Now, we focus on staying as close to upstream as possible, and open source contributions can bubble up from within our teams, as this helps us to reduce our technical debt and reduce the maintenance burden when we use and run that managed open source software. And for many, open source means many eyes reviewing the code, and all bugs are shallow. And in many cases, this can improve the quality as well as the security of the open source software. When we created S2N, which is our Apache 2 licensed TLS implementation, we found it beneficial that we were able to put the code out there and get much more feedback from developers who were able to review that code and provide feedback on what they saw. Now, AWS has been one of the top contributors to open source for many years, and we contribute in many ways. We contribute code, we contribute operations, we contribute to foundations, and no single company has done more to foster the rise and success of open source than AWS. In addition to the code contributions that I've mentioned, we contribute to projects such as GraphQL, Java, Rust, Redis, OpenTelemetry, the robotics operating system, Lucene, and many more. And in addition to the 2,500 GitHub repositories that you can use and view today, we also contribute to other projects as well. Sometimes those contributions lead to new projects that we open source, such as the ones that I'm sharing here, including the ones I've mentioned, such as Firecracker and Bottle Rocket, and new ones that are coming out, such as Babelfish as well. Now, across both consuming and contributing to open source, this force multiplier effect is the tide that lifts all boats and allows open source to win for everyone. Combining the best open source and cloud to accelerate business outcomes, enabling innovation and powering digital transformation. This is what the future of IT looks like. And this is how the next 2 days is going to help you on that journey. You can expect to have sessions that will help you get started with open source software and provide great opportunities to network with peers, to connect with others with similar interests, and to learn from others by sharing your experiences. And you can expect to learn more about the critical open source technologies that you're going to need to build your applications and infrastructure. And this will help guide you to where you want to go in your own career. Now, during the sessions and in between the sessions, there are going to be lots of quizzes, and you'll have the chance to win prizes, as well as that all-important swag. Now, events such as OSTech are only possible thanks to the generous support from the sponsors. So I want to thank the platinum sponsors, Red Hat, Reskill and CNCF. So make sure you check out their sessions tomorrow on OpenShift and voyaging the cloud native seas. Thank you to all the other sponsors as well. So make sure that you spend time with them too. So thank you very much for listening. It's now time for the main event. Without further ado, let me hand you over to the first session of OSTech to Michael Friedrich, who's going to take you from infrastructure as code to cloud native deployments. Over to you, Michael. Hello, and a very...
Yeah, thanks a lot. I can say, to Ricardo for giving us the brief introduction. Let me in Michael. And so hello, Michael.
Hi, thanks for having me.
We are so glad to have you. And so we can start. So let me introduce Michael first. So who is Michael and what he's done? So Michael Frederick is a developer evangelist at GitLab, focusing on backend dev, ops, and sec. He loves engaging with new technologies in the monitoring, observability, CI/CD, and security area, and regularly speaks at events and meetups. And yesterday also, I was checking one thread on Twitter and just checked like some of already retweeted Michael's posts, and he's such a great speaker. So you all will be enjoying his talk. And Michael hosts a weekly technology coffee chat called Everyone Can Contribute Cafe. Okay, so you can just join them on everyonecancontribute.com. And if you want to contribute, I can say open source or any of the CI/CD, you want to learn something, then Michael is free to help you. So just reach out to them. And so we can start with the session. So thanks a lot, Michael, again. And
Okay, then let's start. Thanks for the nice introduction. I want to share today my story around how I learned infrastructure as code, the first steps as a developer, coming to cloud native deployments, development, and how this could work in 5 minutes. So this is like a story of my own in the past 10 years. I joined GitLab in March 2020. Before that, I was involved in monitoring open source development, and basically had lots of fun learning things, and also like trying new things and breaking things and other stuff. If you want to reach out to me, you can find me on social under the name DNS Michi. So this is like Michi is the lovely form of Michael in German. Reach out to me on Twitter, on LinkedIn, on GitLab, or on gitlab.com, or you can also find me on Polywork recently. But yeah, let's dive into the magic stuff and basically the interesting stuff. Okay, just a little agenda. We will start out with a developer's tale of myself. We're gonna dive into like learning packaging. What is that? What is infrastructure management? What are containers? Later on, figuring out, there's CI/CD. Maybe we can deliver something, deploy something, and we can become cloud native. A little bit around like shipping stuff faster, and some tips and tricks and ideas to sail everywhere where like the future is bright and we want to go there. My learning journey started some years ago, and one of the most interesting things I also shared with Andy Grabner in the Pure Performance podcast this week was turbo boost from 33 to 66 megahertz. So we had this button on the computer, the PC, the hardware, and I was fascinated. I didn't know what this is, and I wanted to learn how this works. So I studied hardware software systems engineering. And then I figured out, circuit engineering is not my profession. I'm more in the software side of life. Learned about NFC, then multimedia streaming on Linux, later on DNS development. Had no idea about DNS in 2009, but it got a hold on my nickname, so it stayed for a while. I might be naming myself GitLab Michi, Git Michi, but I'm sticking with DNS Michi. So yeah, this is basically... I was curious to learn things. I'm still curious to learn, and also to work all remote. It makes it easier to connect with everyone and explore the world. Hopefully in the future, at some point, travel the world again. Now, when the developer's tale starts, we are starting out to build our own Lego models or Lego bricks. And this is one of the first things I experienced when I was writing my first code several years ago, or like 10 or 15 years ago. You're writing the first web application, you're creating a tarball or a zip archive, and then you send it over to someone else, like maybe email or something else, and ask them, hey, can you please install it? I have a new release for you. And then the question arises, well, how to install it? Yeah, just unzip it. Yeah, couldn't you just write a documentation? And this is like, okay, this is the first impression as a developer. The other feedback you might be getting is, well, the production environment is different to the developer environment. You're calling make install, it fails. Some module is not installed. That's interesting. What's that? Because it works on my machine. So maybe add dependency management. Add something which checks that the packages are installed, like similar to configure autoconf. Totally new language to learn as a developer. Not much fun to learn, to be honest, but still it provided more ways to check that dependencies are installed. Now, coming from the dependency checks, actually the request was, well, we want to have packages. So please go ahead, and our customer wants RPM packages. Okay, as a developer, I'm looking at it and say, hey, the spec file, this looks easy, doing things and stuff like that. But then you need to make, for example, conditions with macros, and this is like where things are starting to break, and it's not easy anymore. The other side is, after you manage to build RPM packages, and other customers as well, we have Debian, we have Ubuntu, we have other derivatives of that. We want to have Debian packages. Now, as a developer, you're sitting in front of it and say, okay, this is a totally new toolchain work. There are so many different things to understand, and my head is exploding. I also need to think about dependency management again, and actually I just want to escape, or just one, I'm not really sure about that. But still, it's a huge learning journey. The other thing is, we wanted to have a build server. So basically CI/CD or something which just executes and automates stuff. So we want that. So ops team back then said, well, maintain it yourself. So, okay, let's install Jenkins and start, or Hudson CI was it back then actually, and let's run it. And then the security team, or like ops doing security, was coming back after a while saying, hey, why does the daemon run as root? Why is the API exposed without password? Why is everything broken now because an attacker found the way in our network? So, well, developers maintaining tools might not be the best idea in that case. The other thing is what we needed to learn over time. Well, we not only need to maintain one single package, we need to maintain architectures. We need to learn how different behavior actually happens on x64 or x68, or specific on embedded hardware with ARM, with different platforms. Then we had a bunch of distributions, and you're dependent on old build tool chains. You have grown dependencies. You cannot really use the modern design patterns you want to do, like C++ 17 or C++ 14 in that regard, or specific other modern JavaScript, because you're still supporting Internet Explorer 6. Or was it 5 back then? I don't know. Still, maybe you want to go back to supporting just one platform because you want to stay productive and efficient. But yeah, this turned out to be, well, we can automate things. We also need to look into not only like packaging all the stuff, but we need to manage the infrastructure, or config management, how it was called before. So the ops team actually deploys the software. So there are different tools out there, and these are just a few examples of, like, the Puppet agent ensures that the latest version installed. Ansible does kind of the same. Chef ensures that as well, and Salt asks, for example, minion agents. So there is a certain way of ensuring that the software the developers create gets installed, that dependency management is being done in there, and a certain learning path is already solved. Now, ops also needs to do more in that, and this is a certain way dev also needs to understand. Like, you can manage the base system, the dependencies, but you can also like manage users which need to exist, that the specific frameworks you need, the container runtimes, the container cluster orchestrators. You need to take care about backups, because, well, you need to take them, but you also need to test them. And monitoring is also a big part. If you just leave it out of your deployment, you won't see anything. You won't get any alerts. So it needs to be done. And it also needs to be done in the workflow, in the process of provisioning something. Now, ops comes back to the developers. Because a developer wants to deploy a new application, and then there are some requirements to define, and it's up to the developer to say, hey, please specify the database size. Or that the ops team says that. I'm saying, I have no idea. My application might consume 1 GB, but over the year it might be a little more. So it's really like you need to estimate things, or you need to know the application and the data being stored. Like estimating the disk usage over a month. Maybe you only get 2 CPUs and not 4 because the vSphere interface doesn't provide as much resources for you. Or in modern times, in the AWS console, you don't get as much resources as you want to. And one other thing is like you're creating architecture which works, but it might be the case that there is a load balancer up front or any specific other network routing, and the application crashes for some reason. And developers are being tasked with understanding high availability and maybe adding that into the application and not needing any upfront proxies or load balancers. So yeah, it's a lot of things being asked for. Now, when we move on into like ops wants things from developers, well, when it comes to monitoring, you need to have certain thresholds. So you get an alarm when something is like expected to be breaking or already broken, like CPU usage goes up beyond, disk is full. And the thing is, when you're collecting metrics, you cannot store them endlessly or in infinite. You need to like think about retention. So like when you store everything, the backend will be full at some point. The other thing is you cannot cover everything with monitoring with things which are already there. So ops might say, hey, I want to see more runtime metrics of the application. So the developers need to learn Prometheus. They need to learn about exporters. They need to learn how /metrics as an HTTP endpoint works. And what is that? No idea. On the other side, you might be asked for, hey, this is amazing that we have a log when an error occurs, but this is like the long stack trace. We need to scroll 10 pages, but we don't really see the error in the first second. So thinking about structured logging, and I was attending a talk from 𝐦𝐞𝐦𝐿 a while ago, where I actually learned about the benefits about structured logging, like making it processable for machines. You can see it or correlate it with metrics. You can immediately see what's going on the machine, because potentially the machine is dead and SSH doesn't work, so you can't see the logs with tail -f. And this goes on. Like distributed tracing comes to play. So what is that? Is that different to an event? Is it different to a log? Oh, spans and traces to immediately see different steps in an HTTP request into the backend, into the PostgreSQL database, seeing that the Redis caching mechanism is blocking, and even more in the microservice world. Now, when something breaks, you need to call someone, or someone needs to be on call. So like some people are saying that DevOps means devs on call. It's actually, well, yeah, we should work together as a team, but it doesn't mean that devs need to be on call, because the ops team will get paged anyways. So there is a certain control mechanism oftentimes. You need to define who the DRI is, the directly responsible individual, who's on call. But it's actually like you're training your team culture and handle it together in a specific sense. Now, when the journey continues, at some point someone said, hey, there is Docker, there are containers, there is cloud native, there are so many new things to learn. But what is that? Now, when I started out learning Docker and seeing the benefit from my own systems, like a small sandboxy development environment, for instance, or from a deployment angle, throwing away all the Debian and RPM stuff I needed to learn, and just using a container. But what are the best practices? So I cannot remember the difference between add and copy in a Docker file. I always need to Google it. And I gave the same talk at DockerCon and was like, okay, it's actually not just me not being able to remember. The thing is, there are so many other things to learn. Like there is the Docker file, it has a specific syntax. Then you have the Docker Compose, which brings up an entire stack of containers. This is a new YAML format to learn. I've seen a builder image in specific use cases, and I was wondering, what is that? And then I started to dig and learn and try. And yeah, at some point I figured, oh, this is actually a best practice. The other thing I was reading, I think it was 2015 or something, the book around Docker and containers and stuff like that. And at first glance, I thought, well, I can use a container just like a virtual machine using a supervisor CTL instead of systemd. But instead, you should be just running one service inside a container. So you can make many mistakes, and I obviously did. The other thing is, there are no, or in most recent times, this got better. We need default Docker file templates, or we need to have every project to provide a Docker file so you can build a container by yourself, or you use the one hosted in the different container registries. So it's easier to start with, and it's not just you clone a Git repository and then you need to figure out how to deploy it. That shouldn't be the case. It should provide it out of the box. Okay, then we need to dive into actually learning how to build these Docker images. And this is an adventure on its own. Like, okay, we have a Docker file. How can we build that? There is a way of doing Docker in Docker, which is some magic Unix socket mapping inside, and then you building an image inside a container and pushing it to the outside. I think this took me some months to understand. On the horizon, or there's a new API with 𝐦𝐞𝐦𝐿. This doesn't need root daemons on the side. Podman is being developed, but to my knowledge, it's not 100% compatible yet with all the Docker features available. And the other thing you need to think about is, it's fine to build everything and leave it there. So like you're creating Git repositories on GitHub or GitLab, and you don't clean it up because, yeah, it's just there. Nobody cares, basically. The thing is, like, creating Docker images is also consuming disk space in that regard. At a certain point, disk space is running out, and the typical df-h checks don't work, so disk usage. Just because Docker is using a different virtual file system and other things in the background. So you really need to analyze what's consuming disk space, and not just doing an rm-rf, but instead like Docker image prune, something I need to Google again, just to ensure that you're not breaking anything and freeing up disk space for future operations. Now, lots of things to learn, but it doesn't stop here. The other thing I figured out was, okay, now that I have a Docker image, I've built it locally, it's amazing, I've tagged it, but actually I want to make it available for others. And there is Docker Hub, obviously, but what if I'm in a local network in a DMZ or something else? I want to just have it next to my Git hosting repository or something like that. Now, there is the possibility to use the GitLab registry, the GitHub registry. There's Quay.io. There is, I don't know, there are specific other vendors who provide that. And you can also self-host it with a project like the Docker registry project. But you need to figure out how to make it secure, how to push there, or how to log in, and then build the image, tag it, and push it. The best thing is, and this is an example from the GitLab configuration, you're using a built-in template and it does all the magic for you. But getting there is a learning process. Yeah, and like relying on the specific backend daemons who are required for doing so, like Docker and Docker in that example. Yep, lots of things to learn. Now, automating everything and diving a little more into what is continuous integration, continuous delivery, or continuous deployment. At first glance, we started out, well, let's start with CI. Let's start with the simple things. And at a certain point, my branch commit history was a little longer because, well, I couldn't figure out how to create the best or the correct YAML. And this was just trial and error to figure out how the format works. This got better over time with now pipeline editors and linting and automated checks and stuff like that. But when I started out with that, I think that screenshot is 2 years old or something. It is lots of trial and error, and everyone on the team tries that. Now that you have your first success, it's amazing, but the pipeline is taking 10 minutes to run. So you might be queried or asked to optimize that. Especially because every time a pipeline is running and you're creating an MR or a PR, you need to wait for that. So it's like you cannot do anything. You need to focus on other things or use 𝐦𝐞𝐦𝐿 303 as an excuse. And yeah, it's on the way to like learning how to optimize it. And at a certain point, developers become ops because, well, please fix the CI/CD pipelines because you are maintaining the configuration. You're responsible for that. Yeah, and why should I do that? Yeah, they consume so many resources. And then like how? Yeah, maybe the documentation is there. Someone wrote it, ask the community and do something about it. So it's like, again, learning, and especially diving into areas you might never have been before. Now, well, this is only a summary of what you can do or can start with to identify bottlenecks. So like identifying the pipeline duration, seeing the critical path, like the minimum and the maximum duration inside the CI/CD pipeline, looking at stages and jobs, dependencies, sync runs or async runs in that specific regard, identifying patterns of failed jobs from flaky tests. So one time at the day, the tests are running good. The other day, it's like something is broken, and maybe you can correlate that to specific network latency events or something else is like influencing that. Similar to containers, dependencies being installed all the time, packages and stuff. Yeah, and security and firewalls and network and all the things. It's like you need to know a lot and learn a lot. Now, diving from the ops requirement of running a CI/CD pipeline, going into like deliver and deploy, because, well, when I want to deploy my application, I need to think, or at least as a developer, I don't care, but at a certain point, I should be knowing about like the environment for operations. Like, am I using a container orchestrator? Should it be like Docker Compose, Swarm, Kubernetes? Or on the other side, am I provisioning an AWS EC2 instance with using infrastructure as code, something like Terraform, Ansible, automation? And the last thing is like, it's not only installing the application one time. You need to ensure that they are running. You need to ensure that the boxes or the application and the operating systems are upgraded. And potentially you need to do some hot fixing and security bugs. That's all you need to keep in mind for that. And at a certain point, we're back at, hey, developers are now packages again, like cloud packages. Because, well, the Docker image best practices are still there. We have shifted from, okay, it's not RPM, it's not Debian, it's not a tarball anymore. It's a Docker image. But still, we need to think about like builder images, one thing. And the other thing is like keeping the images small. So it's not like pulling a 10 gigabyte Docker image all the time, if we can make it smaller. The other thing is like, okay, there's Kubernetes. Do I need that? If I need it, how can I learn it? And to be honest, it took me quite a long time to really find the use case, find the way of saying, hey, I have understood it. I know how to write the YAML configuration and not just doing copy paste from some specific documentation or tutorial I found on the internet. Next up, okay, what is a help chart? How can I install applications and software inside Kubernetes? What is an operator? How can I make use of that? How can I include that in my DevOps workflows to ensure that the application is not only developed, but also deployed in the right way, setting the right ports which are exposed, adding additional configuration for logging, persistent volumes, and other things. And last but not least, there are some toolings around that. So like packaging a web application, an Node.js application, you are just throwing into an Heroku-ish builder and it does some magic and you get a Docker image which exposes a port and runs the web application. The other thing is cloud native build packs, which is a similar idea. Sitting in front of it and say, okay, this is useful, but how can I make use of it? How does it solve my problem? Still, it's a huge learning journey. Well, and then there is something like auto DevOps. So like thinking around, hey, maybe I can optimize all of that, saying, okay, I'm committing it and it gets deployed to production. So you don't need any extra configuration. It detects all the things similar to using cloud native build packs, for instance, builds the images and deploys to Kubernetes and hyperclouds like AWS, GCP, Azure, and whatnot. This would be amazing if that works. In specific products, it works already. So this is one of the ideas you could potentially be looking at. But the thing is, I need to understand the black magic, because especially when it breaks, I need to fix it. Now, well, after all, as a developer, I just want to deploy my web app. I don't really care whether it's Kubernetes or it's EC2 or something else. Now, how can I really say, hey, I want to become cloud native in 5 minutes? This is like tackling all together and some recursive infinite loops and stuff like that. The thing is, let's go back to saying, hey, what is the goal? What is the side from the developer? Obviously, we want to deploy fast. So we want something to build it automatically. Tests should be there. Tracing, scanning, security scanning. This should be like somehow automated. Deployment should be automated, and at a certain point, when security fixes are done by Dependabot, or I think there are different tools out there which can be automated. Maybe adding auto merge, but in a sense of combining it with security scanning, so that no one injects some crypto mining stuff or whatever into your pipelines or your code. Now, getting there is again a learning journey, and then defining the resources, analyzing what's needed. Like, okay, we need to provision cloud resources for that. Becoming cloud native. Maybe we will be using virtual machines. We will be using services. So not installing a PostgreSQL database, but just using Aurora. I hope I pronounced it correctly. As a database service in AWS, for instance, or for example. I could be using a Redis cluster. To be honest, I have no idea how to run it. Okay, read the documentation and make it work. But still, I just want to consume it. I want to provision it. And I also want to use object storage, using S3 or something compatible in that way. The other thing is, or the other way I need to think about is cloud providers have an API. I need to interact with the API. Hopefully there is an SDK in my preferred language, for Ruby, for Golang, for whatever. And I also need to think about user management. And this is something where it's a mix of dev and ops, defining the requirements and then actually making use of that. Now, when we're developing an application, we might be needing certain additional things. Like when it's a web application, we might need a persistent state in the backend. So it's not just in memory, it's somewhere persisted in a database, in a file system. Accessing the domain or accessing the application over an HTTP port may need a domain and a fully qualified domain name. So registering a domain and ensuring that DNS is up to date. Speaking of that being up to date, TLS certificates with Let's Encrypt are necessary, are important. This is something which you can also automate with specific ACME challenges and whatnot. Still, it needs to be automated. And if there is the need for specific TLS endpoint with an Nginx proxy upfront, for instance, just routing into the containers, this is something which also needs to be done. So this is a requirement to be known about, but hopefully we can automate that. The other thing is, like, for automation, we can really use what we've learned earlier about infrastructure as code. So we're using, for example, Ansible and Terraform to provision the cloud resources which are needed. It's like infrastructure as code just means you're describing what you want to see or what you want to have in a codey way. And it's not like clicky bunty or like clicky bunty doesn't work in English. It's not like clicking in an interface and it's colorful. You really automate that. So the other side is like inventory, seeing what's actually provisioned, what is generating compute costs and whatnot. With a deeper integration into the Git backends or the Git repositories, you can, for example, use GitLab as a Terraform state backend. You don't need to have any specific other things around it. It's just there. You can make use of it. And you can use the ICD variables to actually create pipelines which do the deployment and parameterize that. So like instrumenting the pipeline to behave as a release pipeline, as a debug pipeline, as a staging pipeline and whatnot. Okay, long story. Going or taking again what is already there. Maybe we still want to use auto build, no Docker file. We don't want to learn about Docker in that regard. Want to use auto build and the heroic build at the cloud native build packs. In that specific example, it's important to say, hey, I just want to build the Docker image or the container image, then push it to the container registry. And once it's there, it's exposed to the internet, basically, or in my own environment. And I can decide what's being done at the next point, which means like I'm inside CI/CD. It gets deployed at a certain point. But before it hits the deployment, we need to ensure certain things. So the deployed app needs to pass quality gates, like code quality is something happening and decreasing the code quality. Is the algorithm getting more complex, the architecture more complex? These are checks which can be automated based on open source tools. The other thing is like service level objectives. Like my Git commit changed the performance or decrease the performance because it consumes 10 times more memory. And this is something you can actually detect in a staging environment being run. And the SLO reporting, basically, for example, with Captain shown in the screenshot, can detect that and can prevent that actually this is being pushed into production. Next to the obvious shift left in security, where you're checking against things you probably never imagined. And this ensures that nothing which is vulnerable or malicious gets pushed into production. Having that in CI/CD in the deployment also provides you a single source of truth. So you know where the current state is. You know where the Terraform state is, for example. You know how the infrastructure as code gets provisioned next to the code itself. So you can make use of infrastructure as code, CI/CD templates, and also reuse all the best practices others already have learned and work together on a common solution and not just reinventing the wheel all the time. The other thing is, as a developer, it's similar to Kubernetes or to the deployment. I don't really care how Terraform works. I want it to work. And if it's there, I probably won't be touching it or just reusing a template what's already there. And infrastructure as code can be used to provision the virtual machines or the resources, and later on does the inventory. If I don't want to use a container cluster like Kubernetes, I don't use it. That's it. And optionally, when everything is working, I have the way of like learning things like Terraform, CI/CD, AWS, multi-cloud, monitoring and observability, all the fancy things. And when you get the time, and the slides will be shared after the talk or right now, I will totally recommend watching the video which is embedded here, like how we are doing monitoring and observability and metrics and scaling for GitLab.com SaaS. So you can get an insight what's... Actually, I didn't want to do that. Next slide. Just to see how things can be done and how this has helped all with deployments and automation. Now, if we want to ship things in 5 minutes, 5 minutes is a really really rough goal. And using all these things like a template, where using credentials in AWS, you commit something, you push it, it provisions the cloud resources, it builds the application, deploys the container, and on top it adds DNS, TLS, and whatnot. And this is something we started out earlier this year with the 5-minute production app at GitLab, which provides you a CI/CD template you can just include, and it does all the provisioning into AWS. This is one of our visions which we have, and it also shows the path forward on saying, hey, as a developer, I want my app being deployed in 5 minutes. I don't care how it works in the background. It does it magically for me, and hopefully it does it right and it gets monitored and everything else, which is best practices, works for us. And we can focus on the development, on the things which we are good at, looking into like optimizing the architecture, optimizing the performance, learning about monitoring metrics and whatnot. Now, there is a slight problem with the adventure or the journey over the past years. Like, burnout is real, and developers need to learn so many things that it's really like, you can't just replace a team of 4 or 5 people or 3 people with one DevOps engineer. That doesn't work over time. You will be burning out teams or single persons. So like, you need to really focus on what you want to learn and what you want to do. So when you start out your first learning journey or for your first DevOps adventure, I would say, I would recommend to focus on building bricks. So you start learning in a dev environment. You leave everything which is like all the platforms are tested, that this is like bound to CI/CD workflows. This is something which runs when you push the code automatically, but it doesn't need to be on your focus right now. The other thing is, you want to use infrastructure as code for automation to deploy faster at a certain point in your learning journey, but not in the beginning. Don't feel overwhelmed by that. The other thing is, learning alone is oftentimes hard, and sitting in front of an online course is also oftentimes hard. Try to ask a friend or join a community to do pair programming, group debugging and stuff. Yeah, one of the things, and this is a blog post I wrote this week with Marcel, is like, shift the development environments to the cloud. So make it easier to contribute, because local setups differ, the errors too. You can easily join a team. You can do a stream where you develop something together, like we started out learning Rust a while ago, just in the cloud, in the browser, because the environment is already there. And it's actually Visual Studio Code in your browser. So you can even install, for example, the GitLab workflow extension, or you can install Docker, specific other things which are helpful and really can start learning. And the other thing is, you can share that with your teams all over the world, and also like shut it down and continue at a later stage. And to my knowledge, for example, Gitpod also has a free offering where you don't need to pay in that regard, or at least I think 50 hours a month to learn something new. The other thing is, and I need to speed up. Now we're nearly at the end. It's lots of things to learn, obviously, but I also want to give you some tips and tricks, what's coming, and what you can prevent of. Like, you don't need to know everything. I don't even know everything in that regard. The thing is, if we jump into like understanding monitoring and seeing the value of metrics, logs, and traces, and specific, like, is it monitoring, is it observability, diving into the thing, like, why would I be needing that? And one of the key things is, like, you don't need to be a developer to understand the problem. So those who are not familiar with the algorithm, with the code, with the different files and whatnot, they need to understand when there is a problem. Is it like a bug in the code, or is it the system which got broken, or is it the container cluster which has an issue? Like, is the load balancer network routing broken, for instance? So this is something you need to keep in mind when you look into implementing things and adding more insights into the application for others. Now, approaching this is like a complex topic. And one of the things I would recommend is to start simple. Use a boring solution, like we call it at GitLab. Start with a smaller iteration. Add a metrics endpoint to your application. And then see what you can expose, the runtime of the application, the startup process, the MySQL queries, for example, the specific other timing points which could be of interest, being collected as metrics over time, providing an insight how the application performance is, for example. Once that works, start looking into structured logging, how you can write JSON formatted logs, how to process that, just keeping it simple. The next thing is like building a dashboard with, this is like an opinionated recommendation of mine. Start with Prometheus for metrics and monitoring. Start with Loki and Promtail or Fluentd for logs, and combine that in Grafana. And when an incident is happening, you are clicking on the metrics board or metrics panel on the spike, and you can see the logs immediately, what causes that or what correlates to that. Yep. That's the thing. The other thing I would recommend is don't do everything yourself, because really, like, it's too much to learn, too much to do. Even if in a huge team, you might be seeing that not everything happens and the backlog is filling up. So start thinking about, like, not every written test makes sense, or maybe you're lazy like me and you're not liking to write unit tests all the time. The other thing is people who might say 100% test coverage. Yeah, no, that's not possible. You cannot cover everything in your code. Sometimes you cannot really create a mock or an aspect test for that. The other thing is to think about is like bringing in chaos and known data into the DevOps lifecycle and saying, hey, there are security scanners out there. We can make use of that. Put it in CI/CD, and we get feedback. We can learn how this works. We can act on the feedback based from the security scanning. We can add fast testing, like the unexpected tests for our APIs. We can even introduce chaos engineering into our DevOps lifecycle and say, hey, we're using Litmus chaos, for example, and then defining some test cases, and it really battle tests the application in an unknown environment. Coming from chaos engineering, you also need to practice observability methods at a point, like using the SLOs for quality gates. Thinking about not what is there, but embrace the unknown unknowns. Like, there is something in my system for as a metric or as a log, as a trace, as an insight. is a profile which I don't know about, but actually I can figure it out from the practices, from the things we did together. And the last point I wanna highlight is to say, learn, document it, educate. Write everything down, what you've learned on your journey, be it an issue, be it a log output, be it something else, because others can benefit from that, and do that publicly in the open so that everyone can contribute. Now, we want to sail everywhere, and my recommendation is really, let's learn together. Find those who are creating use cases. So, like, for example, KubeCon and Cloud Native Con has a recording archive on YouTube with use case talks, which are really valuable and insightful. Anna Ulrich's created the 100 Days of Kubernetes platform, which is a huge knowledge base for learning cloud native, Kubernetes, monitoring, and other things. This is a great resource for starting your learning journey. And for live streams, there is cloudnative.tv. And I'm also hosting my own weekly Everyone Can Contribute Cafe, which is like a tech coffee chat for learning together. It's sometimes we touch GitLab as well, but we are keen on learning things. So, like learning Rust, this week we had Civo Cloud with K3s clusters. We had Opstrace, which is monitoring security. So whatever is interesting for us, we want to learn together, and we're live streaming that on GitLab as well, on Unfiltered. So yeah, this is about it, and I talked too much today. Thanks for your attention. Let's keep in touch. I'm DNS Michi everywhere, and now we have a little time for questions, I think.
Yeah, yes. Thanks a lot, Michael, for a great session. So we were having as like some introductory part, or I can say some students also. So they might have some questions. So let me just put in. So the comments actually gone, but let me ask you, like, if there is a term DevOps, then why we need auto DevOps? Or can you elaborate in just some 2-3 lines, like what auto DevOps means to them, or why they can just collaborate it?
You mean why they should use it?
Yeah. So the question was like, if there is a DevOps already there, so what's the difference between DevOps and auto DevOps in, I can say, GitLab CI/CD or something?
Yeah, the thing with like DevOps, defining it as a workflow, defining it as a team culture, is something you need to practice, and you need to find the right tools and the processes for your teams. And if you're taking, for example, auto DevOps, how it's called in GitLab, it's already like it's an opinionated workflow in CI/CD templates and build tools which you can make use of, and you don't need to like learn it from scratch. You can start off like using something which is best practice in that regard and learn from those steps. And like once it runs, once the pipeline is working, you're taking a step back and saying, okay, now I want to understand how it works. So an optional learning curve in that regard.
Yeah, that's a great summary, I can say. And I think we have lots of folks who are just enjoying the session, and I want to thank a lot you. And we are having a quiz, so you can be on the, I can say, on the screen, and let me just add the quiz to the stream. Yeah, so Fox, the first thing I want to elaborate before starting the quiz is like, so this is the quiz link. Okay, we are sharing you in the comments also. Okay, so you can find the quiz link in the comment section. And what you have to do, you have to just go and just join this particular, I can say, link. Okay, and whenever you start joining, you will get your entries here. So you can just find it out. Whenever you are joining, you will get your entries here. So we have already put the, I can say, quiz link in comment, so just join it. Okay, so what you have to do, you have to just put the quiz link in your phone, or I can say in a new tab. Okay, so that's how you have to join it. So I can see a lots of people are joining in. That's awesome. And we have created the quiz according to the session itself. If you have focused in session, you have learned Docker, if you have listened about IaaC, then you must be able to answer the quiz also. So the great thing is like people are joining in. This is the great count. Okay, let's yeah. So I think we can start the quiz now, Abhi, because we have already reached out to time limit, and yeah, whoever joined just joined, and whoever left they can join another quiz. Yeah. So whoever joined, just check the quiz. Okay, you will be prompting something like this, and we are showing the top five leaderboard. Okay, for the top five, we will be having some good, I can say, some goodies or something. So that can be there. Okay, so if you are answering the question, you can just find your name in the top five. So let's start, and all the best. And yeah, this is open for only 5 minutes, not more than that. So just try to answer quickly. The more quickly you will answer, the more there's a chance to earn this facts. Let's see. Okay, so I think no one is answering the question or what's happening. Let us check. Okay, so let's wait. People are answering the questions.
That was nice. Very challenging.
Yeah. Let's wait for more 2 to 3 minutes and we will stop the quiz. Yeah, people are turning the quiz and they are commenting in the chat section. That's a great thing. And I got 80, I got 100. Okay. Okay, that's great thing. Yeah, Abhinit, so we can just I can think I can see that lots of people are just give the 2 minutes also. Let's see who will win the quiz.
Hopefully, there will be someone who is 100%.
Yeah. Let's see, because there will be lots of people who will be getting 100%. But let's see who will be in the top five leaderboard. Because if you are answering all the questions, but if you are taking more time, so it will already take you at the back. Okay, so it's not like if you are getting 100% then you are the winner. So don't suppose that, because I am checking 80%, 70%. But who will be answering question at the starting, like as soon as possible, who will be getting the chance to win. That's the beauty of this quiz.
It's interesting. I have zero knowledge around the NVIDIA platform, so I needed really to guess. But I appreciate the mix. It tells me I have 8 correct, so personal success.
Yeah, let's see. Okay, so I think we can end the quiz. And whoever left, just join us quiz at the next time. Okay, we will be having you, and we will share the top 5 winner for this quiz on our social handles, or you will get I can say social handles by the end of today's meeting after 5 p.m. Okay, so stay tuned for all the quiz winners, and we will be looking out to you. Thanks a lot, Michael, for being a part of us, and thanks for joining the session.
Thank you, and yeah, have great 2 days learning new things, and let's stay in touch on social.
Yeah,
Have
sure.
a great time.
Thanks a lot. Yeah, thanks a lot.
Bye.
Yeah, bye bye. Bye bye. Yeah, so over to you, Seema.
Yeah. Thank you, Aditya. Thank you, Michael, for the lovely session. So the next is we have, so location intelligence plays a key component in our lives as we know it today. And Map My India, with its rich and extensive 25 years of worth experience in this domain, will be presenting how location intelligence can be comprehended and incorporated easily into many real-world problems which businesses typically face in today's world. So let me invite Kunal Bharti on the stage. And Kunal Bharti is an associate vice president at Map My India, where he oversees the development and management of the API products for iOS, Android, web, or any other form of SaaS software while cultivating a market for the users. He graduated from Ranchi University with a Bachelor of Technology degree. He also did his master's in business administration marketing from the Faculty of Management Studies from University of Delhi. Yeah. Hi Kunal, how are you?
Hi. Thank you for inviting me and giving me this opportunity, giving MapMania this opportunity to present on your wonderful platform. Good afternoon. Good afternoon, everyone.
Yeah, we are glad to have you here. If you want to add something else, you can do that.
Okay, thank you for the introduction. So basically, I work as the Associate Vice President at MapMindia. I've been associated with MapMindia for a long while now. And MapMindia has had basically quite a lot, basically 25 years of rich experience in solving location-based problems that use day-to-day basically clients and any sort of clients, enterprises or large government organizations face. The primary challenge and how basically we have encountered people is that comprehending how location intelligence and what role does basically location-based services play in within your apps and tech was in fact and still is to some extent quite a new concept, and people are slowly discovering the power that location intelligence brings to any platform, brings to any application or brings to any technology stack. Whether it be any day-to-day activities like ordering food from your favorite restaurants to all the way to basically hailing a cab. From small things like going out to the market and planning your route, day-to-day route, avoiding traffic, all the way to how even large organizations, large units like civil aviation operates in the world is powered by an efficient use of location intelligence within their apps and solutions. So today, basically, the session will primarily be, the session that I'll be presenting will primarily be involving the main agenda is what location intelligence primarily means within your app, how you can leverage it within your applications and tech, and finally a small presentation on how what is the role that MapMindia has played in this particular field and easing the source, basically providing solutions to the complicated problems, simple or complicated problems which location brings to any particular application or technology. So without further ado, let me just quickly continue. Hello, first of all, welcome everyone, and thank you for joining me and the team in this particular presentation. I'll quickly go through some of the important questions which our consumers face, which I have had the experience of working with many different corporate houses, many different government organizations. The most important concerns, considering the recent dreadful pandemic that we have been going through, is that most businesses' chief concern is which business locations to reopen. Now, this was and still is a point of concern to many businesses, and this question is typically answered by trying to determine, okay, which places are safer, which places are still under lockdown, which places are getting a high concentration of COVID cases still active, and which places are in general. For example, if you are opening a particular business location, then considering the safety of your employees is your foremost concern for any business. And how to answer this question is something that location intelligence answers. Another important question is that, okay, this is quite common, and that which customer's address or delivery point does your solution cover? A very important question that this particular very important problem that this particular solution solves is, okay, I have, let's say I have a delivery service. I'm a local dabbawala. I'm a local basically dabbawala supplying to my location. I have a lunch provider, basically lunch box provider to my local community. Even that hyper local solution also requires you to understand, okay, what is my coverage area? Do I go beyond my coverage area? Will that be economically feasible? Will that give me that return of investment that I make to deliver to that particular area or not? So these are some of the solution, basically questions that location intelligence answers in your apps. Again, from which employees are coming from which area, and what is your employee demographics in the current work from home scenario? A very important question that the recent pandemic has forced the organizations to answer. Now, this particular question will be of most interest to most of the people here, that people get a choice of whether they want to integrate location-based cloud services into their apps or not. But the decision comes to whether it will provide a value. And I can definitely say yes. To most of the use cases, location-based cloud services definitely provide some value to any application. And this is a popular misconception that having location-based basically cloud services within your application does not, or is not that much of a value. I'll just simply show from my presentation that how you can provide a value, and basically to justify, and this question, to justify the solution, basically answer to this question, that how location-based services do provide value. Again, do you want your users to have a location-enabled nudge? Now, if you consider several organizations, for example, several ride-hailing services, they depend entirely on location-based services. They are largely basically entirely operational through automated means. There is hardly any staff. There is only a small amount of dedicated call center support available, but the entire technology stack of most location-based ride-hailing services is powered entirely on a location-based stack. Now, coming from this deep integration of location-based services within their solutions to a small use case where you simply want to know, okay, at which point on the map does my address lie? From all of these different problems, from large-scale solutions to small-scale solutions, so small-scale problems, location intelligence does play an important part of it. So hi, I'm Associate Vice President from MapMindia, welcome. And I'll give you an example of certain industry-based use cases and live applications on how location-based intelligence does provide value in your applications, and explain to you which part or which aspect of location-based services to use within your application. I give an example of live applications in the real world. Now, a store locator services is very popular, and almost all ATMs, any outlets do provide these services if they have a presence on the internet. They want to, for example, if you want to search, okay, what is the nearest outlet of this particular business in an area? This is powered by something what is called a nearby search, which is nothing but you do a small search of that particular premises, that particular outlets around a reference location or within a particular area. Now, this is called as a nearby API, which I'll give you an example that MapMindia does provide. And this simple API or a simple solution gives an answer to how you can discover that particular business's outlets within a location by giving the reference of the user's current location. A simple example of this being that, for example, if you have if you want to search for ATMs of a branch, you can simply search around the user's current location. These are the ATMs near my branch. You can get a direction to that particular ATM by using what is called a routing API, which gives nothing but a direction service, step-by-step direction service of road distance-based navigation steps from your current location to the destination being whatever nearest ATM that you have selected. This is a live example of how store locators are used in many different industry use cases where businesses or any firm has to provide a discoverability of their outlets. It can be any sort of an outlet. It can be a service outlet, it can be a showroom, it can be anything to their consumers. FMCG. Now, fast-moving consumer goods typically have a problem of providing discoverability on the basis of, okay, where do I deliver my goods to? Now, this there are a lot of basically e-commerce platforms which provide FMCG-based deliveries, basically pantry services, services which tend to provide you deliveries within a couple of hours because they promise the freshness of the goods. Now, for such services, typically the most common problem that they face is the delivery location. Now, delivery locations can be very confusing, considering that India does not have a very standardized address system. You get from a very structured addresses in planned cities such as Gandhinagar or Chandigarh to very unstructured addresses in basically urban conglomerations like Delhi. Now, Delhi itself, for example, Delhi or Mumbai has certain sections which are planned sections which will have a very defined address hierarchy. To also, they will have those sections of the city which won't have that much of a planned infrastructure or a planned address hierarchy. Now, this is quite confusing. If you are to go and deliver on the basis of just a poster address without any digital component attached to it, without what is generally termed as geocoding. Now, geocoding as a service, what it does is basically converts a real-life human-readable address to a coordinate, to a pin on the map. How typically FMCG services solve this problem is either they ask for the user's address, which you must have seen in a lot of applications that they ask for the user's address in a structure or in a single line text. And then they also sometimes ask for the user to put a pin on the map. Now, putting this pin on the map necessarily means simply by, okay, that this is the location that you want to deliver your goods to. Now, this is a very simple example of how maps and location-based tech can be included in a goods in an e-retail business, FMCG-based e-retail business, wherein you can get an assurance that since you have the exact position on the map, so you can definitely go to that particular location. One, by having from the pin on the map, the other way around, by deriving the address from the pin on the map, or by entering the complete address and getting the latitude, longitude, or the geocoordinate information. To fetch the address from the pin on the map, the mechanism is reverse geocoding, which does the other way around, simply by taking the coordinates as an input and providing a full human readable address. And the geocoding, as I already explained, is the process of providing a full human readable address and converting it into a latitude, longitude. Another example is that people tend to provide a field wherein they can basically type any address, and the search results come in a list. And as you are typing, the search results basically gets refreshed on the more characters that you type in. They get more filtered out, and you get to the point that you get your desired address in the list, and you simply select from the list, and your address is detected. Now, this is what is typically called an autocomplete or an auto-suggest API. Again, all of these services, FMCG-based apps, typically have multi-platform support. They do provide maps-based, basically pin marker-based support on their web applications, their Android or iOS applications, and location-based services are typically available for all of these platforms. This is an example of, on the left, this is an example of location-based services and the same pin on the map being done on the mobile phone, and on the right, it's an example of pin on the map being done on the web applications. Now, again, an example, real-life example of food delivery and on-the-go services are also one of the use cases in the industry where location-based services have started playing a key component, a key role. Is that when you order a food from any on-the-go services, you tend to get two aspects. You first need to provide your address. It's again goes to the same mechanism that you either provide an address through geocoding or pin on the map. And the second component is that you are able to see in a map the food coming to your location. You are able to see basically what is called a live track of the delivery boy or the delivery agent coming to your location. Now, this is a very good example of providing real-time feedback through the use of location-based services to your consumers. Why? Because this provides an ease of mind, a very good user experience to your consumers that yes, there is a transparency that I can see in real time that the delivery agent is indeed coming to my location, and if he or she strays from his or her location, I can definitely call him or her up and do a course correction. An example of how on-the-go services use map is provided here. Now, some of the components that on-the-go services typically use is they use, first of all, they use maps, and they provide search services. For example, they tend to provide nearby search. They tend to provide a specialized subset of nearby search, which is called a point of interest along the route search, which rather than searching around a particular reference point, searches along the route. For example, if your delivery agent is already following a route from point A to point B, and he needs to pick up basically from the restaurant which falls on his route, he can simply search, the application at the backend can simply search, okay, this is the restaurant that falls along your route, which has the ability to fulfill the said order of the user, and he can simply select that particular, the system can simply select that particular outlet. The driver then can simply pick up from that particular outlet and proceed towards the destination. The next example is, of course, what is called a place detail, which provides not just basically address components of a particular place, but details like, okay, to what timings does that particular place remain open? For example, if it is a store, if it's any outlet store, there is a timing associated with it, that these are the business hours that this typical store is operational. And thus, there is basically the user gets a sense of, okay, this is the point that where the store is particularly operational at, and you can basically go to that particular store. And if it falls outside of the time window, then you may not. Time windows are one of the things that are provided through the place detail APIs, but it's not one of the only things. There are many details, depends upon use case to use case. Restaurants typically have time windows. They have what type of foods or services that are available to them. For example, in the current use case, do they follow the latest safety standards? Do they have vegetarian food? Do they have non-vegetarian food? Do they have, for example, if they have a menu-based services, okay, do they provide continental? Do they provide Chinese cuisine types? So basically, all of these services are typically related to place detail API when it comes to location-based tech. And again, finally, if you have already want to know, this is basically to know which is the nearest outlet that can serve a particular user's location, you need to know the address of that user, which typically most smartphones have the capability that they take the user's location, either automate through the automated process, through the OS services, or they simply ask the users to share his or her location. And once the location is shared, once the app has the access to the coordinates of that particular user, they can simply do a reverse geocoding, which is coordinate to complete human readable address and present it to the user that since you are residing in this particular location, the store that will serve you will be this. Another example of the same situation, basically this particular in this particular use case, as you can see, the application is simply asking the user to confirm his or her location, and on the basis of his confirmed location, his delivery store will be confirmed. Now, e-commerce. Again, e-commerce as a service also has many. This particular use case takes care of many different types of APIs, from any basically location-based APIs as such. Of course, maps is primarily one of them. Reverse geocoding, again, quite important. And it may interest you that any UPI-based transactions in India, the UPI applications are actually bound to capture where the UPI transaction took place. So whenever you transact, whenever you do a transaction on UPI, the applications tend to capture your location information. They capture the latitude and longitude. This is mandated by government basically policies. And since they capture the location information, they are also able to tell, basically through the use of reverse decoding API, capturing the latitude and longitude, converting into the address, that where actually the transaction took place. So e-commerce as a platform basically captures your location so that they can tell you which are the retail outlets which are applicable to you, which of the retail outlets can actually serve to you. If you notice that many e-commerce applications tend to ask you for your PIN code, and on the basis of the PIN code, they are able to tell that which of the offerings on their platform is deliverable to your location or not. This is through the use of a deeply integrated location-based tech at their backend, through the use of which they derive this particular information, that whether a particular good or a particular type of a service is available to the consumer or not. Again, an example. They do ask for your delivery address. So that is, of course, provided by either a pin location or a geocoding-based search. After you have basically ordered a particular location, some e-commerce applications also allow you to live track your shipment, basically to see where it has reached, and so that you can basically see it on the map that, okay, it has been shipped. It has been shipped from your warehouse. It has already arrived at your regional warehouse, and now it is out for delivery. So for all of these basically small problems, location-based tech at the background plays a very important role. Payment, again, as I said, UPI already has a very important policy that it does capture your location information. Apart from that, you may also notice that certain payment apps provide you what are the nearest merchants which support their services. So this particular feature is also taken care of by location-based tech, by location-based APIs such as reverse geocode and maps, of course. As you can see, one of the most popular, one of the largest payments app in India does use MapMania-based APIs, map APIs and SDKs, wherein they can provide you what are the nearest businesses, depending upon the different categories that they have, and which business categories among them actually take that particular payment platform as one of the payment services. Few more screens which show you the same. Now, automotive is another sector where location-based tech has long been involved, and not only to provide basically navigation from one place to another. And this was the legacy mechanisms that typically, when we talk about automotive sector, we used to think about, okay, location-based tech in an automotive sector typically only means providing navigation services from one point to another. Now, automotive has expanded, and almost all the vehicles that you see right today are more connected to the internet than they were. Now, since they are connected, they are always connected to the internet, they can provide a lot more value addition to the user. For example, they can provide you, okay, how much time did you spend on the road moving? How much time did you spend while idling? How much time did you spend while the ignition was on and you were standing at a stop line? Maybe you could have switched your ignition off and saved X percentage of fuel. So all of these services, which take into account that where all you have been, provide a real-time driver analytics, provide tracking-based services in case of a stolen vehicle. They can also provide services like, for example, okay, you have parked at this location. Where have you parked your vehicle, so that you can easily find it, especially if it's a large parking location. All of these services typically use location-based tech in the backend, and all of you, as you can see, they provide a very intuitive and a good user experience through the use of location-based tech. They provide an extreme value addition, and some of these components are indeed marketed by automotive apps as their unique selling points to give them a competitive advantage over their competing brands. Again, one of the good examples that we recently have is due to the pandemic, one of the largest luxury car manufacturers in India also offered basically COVID-based information within their own infotainment systems. Now, infotainment system is the in-dash system that you typically get in a car, where you see navigation and other such components already being implemented there. Now, apart from that, they also offered things like which is the nearest COVID treatment center, which is the nearest COVID test center. And such enhanced services, such extensibility of infotainment system is only possible if you have a very deep and a very scalable basically connection to any location-based cloud services provider. For example, this particular luxury car manufacturer did a partnership with MapMyIndia to provide these services on the go, and even in their already sold vehicles, this was simply a software update which they did in the background, and all the vehicle owners started to get this information streamed onto their headsets or their infotainment systems. Another example, which I already told, is the ride-hailing services. They also use almost all of location-based techs. This is a very deeply integrated use case wherein almost all ride-hailing services use search through the use of AutoSist API. They use maps. They use Maps SDKs to display maps. They use routing functionality to give driving directions to the user. They have inbuilt navigation to provide so that their drivers can drive from point A to point B. And all of these services, they are deeply integrated, especially all of the ride-hailing based services that you see right now out there in the world are deeply integrated with location-based services. A good example, if you must have noticed, 𝐦𝐞𝐦𝐿 website also had a very deep integration with location-based tech. How they used to provide discoverability of basically vaccination centers was through the help of location-based components. They either provided you to search your vaccination centers by PIN code, they either provided to you to search your vaccination centers by district, and also to search your vaccination centers by map, in which MapMyIndia had a contribution towards the COVID government initiative. So all of these components, as you see, even the government, for small things, for such important things, these are just small components which in turn make a very large impact to the consumer. And this was a very good basically initiative done by the government to provide such search location-based search services, because it makes a lot more sense for people to discover if they already know, okay, what is the district, what is the PIN code, and if they don't know their PIN code, then they can simply search their location on the map, or on the basis of the user's current location, they can simply search what are the nearest vaccination centers and what is the status of the said vaccination centers. Now, as you can see, in almost all the use cases that we have presented till now, they have a very deep connection to how location-based tech is used. Now, continuing on, skip. It is our belief that location-based services have been the single biggest shift on how businesses reach their consumers. Now, as I've already explained, we are welcome to if you provide your valuable opinion as well in the chat on how you see how location-based services have been providing basically value to the customers, and how you deem that they can be utilized or they can be leveraged further to provide more value to the customers. But I hope some of some of the use cases provide you an idea on how location-based tech can be used. Now, location-based tech can be used for people, for any or all type of consumers, for employers, for vendors, for intermediaries, for retailers, warehouses, or for firms, whether they be large enterprise, government departments, or large manufacturing industries. Now, all of this, the one thing that can tie all of these different components, these intermediaries, the folks, and the large firms together, we think is apps. Apps as a component and the latest GIS and tools developed on rich maps are utilized within your apps to make them location aware. They provide a great value. They provide a deep insight into how your applications have performed in which locations. They provide analytics to you as well as enhance the user experience for your users. People tend to associate that mapping is quite complex. Yes, mapping is complex, but using mapping solutions is quite easy. As you have already seen from the way almost all of these use cases have deeply integrated location technologies, using mapping is easy. It's just that you need to understand, okay, which component of mapping is required where. And once this clarity is with you, then simply picking up and choosing from the wide variety of mapping solutions is a piece of cake. And this is where MapMyIndia as a platform, actually, as a firm, can help you. MapMyIndia maps and services are on everything based, location-based tech are available. We have easy to integrate tools to empower any location-based modules for your applications and website. I'll just take a couple of minutes time to quickly scroll through the different services that we have available. We have a rich API library, which can basically you can use to do an interactive map display. You can do accurate building level geocoding. You can do reverse geocoding. You can provide turn-by-turn directions and guidance to your consumers. You can provide nearby POI search. You can do basically type-as-you-go auto-suggest search, integrate auto-suggest search APIs in your applications. Almost all of our rich map data is all of it is hosted on the AWS platform, and thanks to the AWS team, it's highly scalable. It is highly secure, and we have multiple platforms. We have our mapping platform, we have our IoT platform. We also have recently come up with our own analytics platform, which all of these power our SDKs and APIs, which in turn power our own products as well as third-party applications. Some of the APIs stacks which are available from MapMyIndia are maps and traffic, routes and navigation services, search services, and as I mentioned, geoanalytics services. Some of the map SDKs which are available from us are in basically the map SDKs for your web, map SDKs for your fluidic map integration in your mobile apps. We have navigation SDK, which is a unique selling point for MapMyIndia, that we are one of the sole providers of navigation SDK, which provides navigation embedded within your app rather than calling out a third-party app. Just give me one moment. Okay. Okay, where does the map SDKs usually help? They provide visual awareness to the user's location. They allow for animated visualizations about your services on the map, and they help correlate virtual references to the physical twin in the real world. This is how maps as a map display, as a platform, as a service, basically provides value to any use case. Now we have our search APIs, which basically turn the real world locations easily, and basically it provides varying filters to narrow down the search and put a place on the pin on the map. We have the type-as-you-go search. We have the geocoding API. We have reverse geocoding API, the nearby API, which searches for nearby places according to a given category in a location. We have place detail APIs. We have text search APIs, which tend to take in a lot of, which tend to incorporate a lot of machine learning to make sure that even vague statements can be converted into geographical components. And we have what is called an address standardization API, because India as a address structure is quite haphazard. So we have an address standardization API which can transform postal address, even if it is non-standardized, into a standardized admin hierarchy. Where does this help? Basically, search services typically help because users tend to know their location in the form of postal addresses. But to resolve them into digital addressing is where the search APIs actually work their magic. We have the MapMyIndia routing APIs. MapMyIndia routing APIs basically solve the complex routing problems for fleets, enterprises, and individuals. They provide comprehensive and updated, accurate turn-by-turn navigation between two or more geolocations. Some of the routes and navigation APIs that we have is routing APIs for passenger vehicles, for heavy vehicles. We have our own navigation SDK. As I mentioned, you can embed navigation within your app rather than calling out another application for navigation. We have the distance matrix API, which provides driving distance and duration between two or more points with or without live traffic consideration. We have routing APIs for two-wheelers. Again, all of these APIs can take into account live traffic information, which basically provides congestion addition to your ETAs, and basically provides real-time ETAs on the basis of the actual congestion on the route. We have snap to road APIs, which basically matches any raw coordinates. This is quite useful in telematics use cases, wherein you get a GPS coordinate which is not matched to the map road network. So this is actually matches the raw GPS coordinates to the road networks, the travel route image API, and the peer along the route API, which basically searches for peer along the route. How this helps is basically it gives driving direction to any place to your users. It calculates the driving time or distance-based reports to plan logistical operations in your solutions. You can also do driving range-based polygons on the basis of expected distance or travel time. You can match your raw GPS location to road network. I'll quickly skip some part of it. The Genetics APIs basically provides analytical solutions to geographical queries, basically visualization on the basis of certain geographical queries. For example, draw all the districts in, let's say, Uttarakhand, where the population exceeds a certain parameter. So on the basis of certain demographic or socioeconomical values, you can do basically analytical operations and draw the said geographical elements on the basis of input queries. This is where Geanalytics APIs basically tend to provide value, wherein you want to basically draw on the basis of your own data or on the basis of existing socioeconomical or demographic data. Now, our search APIs are basically a bit customized to the recent situations on the basis of all the recent keywords that are more basically contribute more towards the recent happening in the recent situations around the world. We tend to make our keywords more dynamic. So our search is more real time. For example, if you simply type in COVID, since COVID is a very ongoing problem at this moment, so we tend to provide more search results related to COVID, and someone simply types keyword COVID. So our search is more keyword driven on the basis of the more popular keywords according to the current situation, and so on and so forth. Hello? Yeah. I think someone is,
Yeah, hi. Yeah, hi, Kunal.
Hi.
So I think, so we are having lots of questions. So
Okay.
let me introduce our something important is left.
Mm-hmm.
Because there are so much good questions are there. So let me ask it one by one. So
Okay.
thanks for the great explanation, and I can see a lots of good comments in comment section, and those were so awesome. Okay, so people have questions like all are these APIs are free for use?
This is a freemium service. Some of the APIs are free for use up to a particular amount of transactions, and after this, basically you can basically opt for more transactions on the basis of a business agreement with MapMyIndia. It typically depends upon your use case to use case. So our solutions is tailored according to use cases. If you have a particular use case, you can contact us at our website. It's mapmyindia.com/API. You can contact us, and if you have any basically questions related to commercials, of course there is a certain limit which we provide as a part of the freemium offering for evaluation and such purposes. But if you have more such questions regarding, if you have enhanced requests that you want to, the free transaction limit is not suitable enough for you, then you can definitely ask for more transactions on the basis of some commercial agreement that you can have with us.
Yeah, that's a great explanation. And the next question is like someone asked, like, I hope government also use this API. So yeah, I already know the answer, but you can explain some of the names that are already your customer or that are using these APIs.
Okay. Okay, I can provide you the most recent ones. So CoWIN is one such use case where government definitely used our APIs. And if you have perhaps heard of Umang. Now, Umang is a digital application platform by the government of India. It's powered by the Digital India Foundation, I think. And it has a lot of services, such as it connects to all the different government departments within the government of India, for example, Indian Oil, and many such services even for rural sectors, such as basically e-farming. So all of these services are integrated within Umang, and Umang as a platform uses MapMyIndia's services. You can go to the Umang website as well as the Umang app, and you'll be able to see our maps integrated. Apart from that, there are many other services. For example, DGCA uses our services for drone registration systems in India, which is Directorate General of Civil Aviation, uses services provided by MapMyIndia. Then GSTN, which is basically Goods and Services tax system, also uses our services. And many such government departments, such as Telangana Police, and I can basically go on saying names and so on and so forth. But many different government organizations.
Yeah, I got it. Thanks a lot for this explanation. And the next question we are having, like, what if these services is provided in ambulances where the person and the driver can track each other location? So this is something like an idea. So if this can be implemented with using the MapMyIndia APIs.
Yes, it can be implemented, and yes, one of the largest ambulance service providers in India already uses our services.
So great.
Yeah.
So I think we are finished too. So we are having a contest. So can you explain it, Kunal, or let me explain it? Yeah.
I can explain it.
Sure,
you can go ahead after that. Sure. Basically, if you have had a chance to basically view the entire session, sorry, I have had a lot more information from my aspect to basically tell you. I had some more interactive sessions, some live demos that I wanted to present, but since we have lack of time, then you can go to visit our website, mapmyindia.com/API, and the questions that we have are such. For example, if you have any use case. Now, there are a couple of questions. The first one being that in all the use cases that we presented, how do you think that location-based tech can be leveraged more efficiently? How it can be leveraged more efficiently, and how more of the location-based services can be implemented in a particular use case. And how do you deem that, according to your understanding, that location-based services provide value to that particular use case? That was question number one. And this question number two is, in a particular use case of your choice, you can pick a use case according to your industry, according to your particular, basically any application that you have had to work on, or any application or a solution that you have had a chance to explore. If you have any such use cases, then how do you deem location services will be more impactful in that particular use case, and how? You can basically provide a detailed answer that how do you deem that in your particular use case, location services will be more impactful, and why? Give a reason why. And the last question is, this is a specific question. Now, this is a particular use case driven question, that if you have let's say if you have a store locator based service, wherein that you have to integrate location based tech from MapMyIndia, which of the APIs and SDKs would you use? And you have to make sure that this is a store locator based service wherein you have to also provide field force analytics component as well, as in that whenever your agent goes to that particular store, you have to basically monitor that particular user and give an idea that, okay, how would I monitor that particular user? How would I get so and so information on that particular user? So you have to tell us what all information you can derive from which of the APIs and SDKs provided by MapMyIndia. And for that, you can visit our website, mapmyindia.com/API, to know more about the APIs and services provided by MapMyIndia. The last question is very specific. For a store locator based service that has a field force monitoring use case component embedded as well, what would be the APIs and SDKs provided by MapMyIndia that you would use, and why?
Yeah, that's a great explanation. And let me sum it up for you. All the participants are there. So what we have done is we have just checked the video description there is a Google form is already there. Okay, so what you have to do, just so as the three questions Kunal sir already explained, so what you have to do, just think of an idea where you can use the MapMyIndia APIs, or if you have a like any of the startup idea, or where you can use, let's say you are like there was a question for ambulance. So if you are assuming that ambulance, if you will use MapMyIndia API, so how that can be benefit to all the people. Okay, so you can think of these ideas and just sum up the idea with a great conclusion. So description should be a lot of words. Okay, so that particular description you have to write in, I can say in comment section. There's a Google form already there, so you can find it by MapMyIndia, and I can say surprise quiz name. Okay, so the Google form is already there. The Google form is open till 8 p.m. today, so you have to fill it out with all your response. And tomorrow we will be having a session again with MapMyIndia for I can say 10 to 20 minutes. There they will be announcing all the winners for like all the what I can say what are the questions we are getting. So we'll be announcing winner tomorrow. Okay. So hope it answers your question. If you have any questions, then just re-watch the video again, because it will be live and it will be saved. So if you want to recheck the whole video and then want to put the some of the summary, then please do it. You're open to do it. And thanks a lot, Kunal Bharti, for the great session, and we enjoyed it a lot.
Thank you. Thank you.
Yeah, thanks a lot. Yeah. Yeah, hi Sima, over to you for the next session.
Thank you, Aditya. Okay. So the next session is from DevTron, and we have Prakash with us, and he is a Kubernetes solution architect at DevTron Labs, and he has 10 years of experience in IT. How are you, Prakash?
Hi, hi, Seema. I'm good.
Yeah. Okay.
Okay.
So you
So,
can start your session and introduce yourself.
sure. So, like Seema introduced me, I work at DevCron as a Kubernetes solution architect. I have around 10 years of experience in the industry. At DevCron Lab, we have created a end-to-end software delivery workflow for Kubernetes, and it is made on Kubernetes itself. Uh, so I'll be sharing my screen. Is the screen visible? Is it visible? Can you confirm?
Yes, it's visible.
Oh, okay. So I'll be quickly introducing you with what is Devtron and how it works and what are the solutions, what you can build using the Devtron tool itself. So like I said, the Devtron is a software delivery workflow for Kubernetes. And so in this particular demo and session, I would be covering these parts. I would be emphasizing more on the demo part because that's pretty much what interests people in the open source community, and how we can help people get onto it. So first thing is first, why
Hi
Devtron?
Prakash,
So why we
sorry
created the
for
Devtron?
yeah, hi Prakash. Sorry for interrupting, but can you please
Yeah.
click on present mode and start the this again? Just click on present mode because it's not in full screen. We are able to see that Google slide.
Okay.
Yeah, this one.
Yeah.
Yeah, please. Thank you.
Yeah. So why we created Devtron, first of all. So there were a lot of solutions in the Kubernetes vertical, but there was no one solution which provided a lot of everything that we needed for a complete software delivery pipeline. That is why we created the open source Devtron solution, which integrates with most of the major solutions that are present in the Kubernetes marketplace. And while giving you all the flexibility, we also give you multiple abstractions on the level that you won't need to go into the specifics of Kubernetes, while still you will be able to deploy applications and productionize it using Devtron, using a complete end-to-end automated workflow. Okay, so there are numerous tools that we use that we integrate with Devtron that can be integrated with Devtron. Some of them are Argo CD. We use Claire. We use �Y𝐚𝐴. charts. So that was one of the primary concern why we created Devtron. The broken user management is one such thing that Kubernetes community is very skeptic about. So the user management in Kubernetes is pretty much very basic, and we take it to the next level by integrating stuff with Caspian with Devtron. So the solution covers integrates with multiple services within the Kubernetes and CNCF space, and we are more focused on giving a better experience to the users who are using Devtron, and not and the people should not be wandering here and there to search and install stuff on their Kubernetes cluster. So we do it at one place, all at one place. So right from monitoring stuff, we give you a solution for deployments, we give you a solution for GitOps, we give you a solution for observability of your applications. So everything is integrated in one good package that you can install and right away deploy applications on production environments. Uh, I would not be going into the details of the architecture, but basically we have around 14 to 15 microservices. Some microservices are like open source solution that are readily available in the open source marketplace, and some microservices are created by Devfront itself, and it is in open source space itself. So you can just go ahead and fork the Devtron repository on GitHub, and you can even contribute to the Devtron as it is an open source solution, completely open source solution. There's no freemium or ifs and buts. It's completely open sourced. Okay. So I'm not wasting much time in going into the details. I'll be covering the features in the demo itself, but I'll just quickly give you a broad intro. What are the features? So Helm charts are pretty well integrated within the Devtron. You can add any Helm repository that exists, and all we import all the charts from that particular Helm repository, and we make it available for you to install, and just you can use any Helm chart within a click of your mouse, and get it ready and get it deployed at any of your Kubernetes clusters. We support multiple deployment strategies, blue, green, and canary deployment being one, which is not supported out of the box in the Kubernetes deployments. We support multiple cluster and multi-cloud support also. So in one Devtron installation, you can have a Kubernetes cluster from multiple cloud providers and even on-premise integrated within one Devtron solution, right? So and we have integrated observability. Like I told you, you don't have to have a specific tool integrated along with Devtron to use that. Uniform access management is handled with another project, which is the Caspian project. So we use Caspian to provide you a unified and extensive user management system where you can create groups for your environments and then give access to users using those groups. Which I will be demonstrating to you in a while. And then we have some specific features like centralized caching, hibernation, and hierarchical security policies. That would be. So I would be quickly coming to the hands-on. I will be skipping the installation part, which is pretty much documented. If you go on docs.devtron.ai, it's very simple. You can install Devtron using a Helm chart that we have provided in the documentation itself. You can easily do that. I won't be covering that part as of now. I will be just showing you a demo how you can actually deploy a any containerized application on a Kubernetes cluster. So for the demo, I will be covering. So this is the Devtron UI that we have. I will quickly cover some features that I just want to show you. So you can connect various Kubernetes clusters on this Devtron UI that we have. So if you see, I have various clusters connected to my this Devtron installation, and then I can create several environments within the clusters. So I can have multiple non-prod environment running within the same cluster, and while still having a logical partition of environment, and in Kubernetes lingo we call it namespace. So each environment is mapped to a namespace within the same cluster. So I need not have I need not have multiple non-prod environment setup. I just need to connect one cluster, and therein I can have my dev environment, my stage environment, and the pre-prod environment. If you have, then we can connect another cluster which is only for the production environment. So you can do that over here. So you can connect any cluster on this Devtron. So be it a on-premise Kubernetes cluster or a cluster which is hosted with any of the cloud providers. We support all the cloud providers and from on-premise. Then I would like to show you the user access management. Here we handle it pretty well. You can define a group, like here I have defined two groups which give you admin access for one of the environments that we have on this cluster, and then you can add the users to these groups using the UI itself. So I can add any person to a specified group. I can also sort of give specific application permissions to a user. I can also do that as well. Moving on to the chart section, which is the Helm chart section. Like I told you, you can import any Helm chart available in the market, and the Devtron will provide you that Helm chart on this UI. You can just click on any of the Helm chart and just click on deploy. You can give it a name, you can select the project, and you can select the environment you want to deploy it in. You can refer the readme file from this side pane that we have, where you will get all the information about that particular Helm chart, and then you can quickly deploy it in any of your environments. One more thing that we have over here is like we also have a functionality where you can group certain Helm charts. So like I have created this particular infra essentials group of Helm chart, which I install in every cluster that I attach it to the Devtron. So this particular chart group has the Prometheus Cube Prometheus stack for monitoring. It has a cluster autoscaler for infra autoscaling. Then it has a Matrix server. Then it has a Fluent Bit for logging. Then it has an Nginx ingress controller for all the ingresses that we have. So you can configure and create groups like these and deploy it in one click. You can do that with Devtron itself. So that is pretty much the chart section. Then we have a security integrated within this Devtron UI. So you can scan all your images that you are building through Devtron. You can even control the security policy at your organization level. Even you can do that at cluster level or environment level, or even at the application level you can do that. So if you find that you don't want any user to deploy any particular application which has a critical vulnerability detected, you can do that and enforce that using these security policies itself. So that's pretty new feature that we recently introduced. Okay. Then I'll quickly move to deploying a microservice on Kubernetes cluster. So for this, I will get to the application section. So these are the microservices that are deployed through Devtron. So I'll quickly tell you how to do that. So for deploying any microservice using Devtron, you have to create an application. So I'll be giving a name for this, AWS demo. I'll be selecting any project. I'll be selecting the demo. project, then you can either select uh, a template, means any app that you want to clone, any existing app that you have already, which is very similar to your present application that you're onboarding. You can select that application and it will clone all your configuration from that particular app. But for this demo, I will be creating it from the scratch itself. So I have selected the blank app. So I have created this application. So now I can select where my code is. So my code in this case is in GitHub public repository, which is this one. So I'll be quickly copying this HTTPS URL to clone my repository. So this I have put over here. If you have a configuration where you use the code from a different repository, and then you have configuration set in a different Git repository, you can use this checkout path, and you can add multiple Git repositories within the same application itself. In our case, we have only one that we are building from, so I'm just adding one. Otherwise, you can add multiple Git repositories over here. Just next part. Okay, so here you have to provide a Docker repository where you will be pushing all your images once the build are done. So I will be just pushing it to Devron repository that I have created for this one. So I have to mention where is my Docker file. If I can show you over here, so I have my Docker file in src/application, and this is my Docker file. Right, so I will be mentioning this part, src/app, src/app, and this is the Docker file. If you want to provide any Docker build arguments, you can do that over here. In our case, we are not needing them. So I've saved this configuration, moving on to the next step. This is the deployment template. So this is the actual configuration file. This is the one configuration file that Devtron uses, and it configures everything for you. So if you want your application to auto scale, this is the place you can configure that. If you want for disruption budgets to be enabled for your application, this is the place you can do that. If you want if you want to pass some arguments, if you want to pass some environment variables, you can do that over here. So I'll quickly show you. So this configuration is sufficient to work for most of the common applications. You just have to mention your port number over here, and then if you want to configure some configurations over here, you can do that. In our case, I won't be using HTTP2, so I'm just disabling it over here. So I'll quickly walk you through some configurations that are very essential. And for other configurations, you can refer to this documentation that is already there on top. So it takes you to the docs.devtron.ai, and then here are each and every configuration that I have in the deployment template is documented pretty well over here. So you can refer that to see what configuration changes what. I will be covering some configurations for you. So container port is something. So what container port you want to expose your application? I mean, that's pretty much what the same that you do over here, and you using the expose command. So the same container, you will be mentioning it over here. Okay. Then there are liveness and readiness probes, so that you have to mention. So liveness and readiness probes are pretty much work like health probes, health checks. And the Kubernetes heavily relies on these probes to maintain the state of your applications or your deployments. So make sure that you have liveness and readiness probes set in all the production deployments that you are creating using Devtron or any Kubernetes or even in the Kubernetes, right? So So that you have to do that over here. So you can mention a health check path like health, or something like ping that your application is made to respond at. You can do that over here. The same goes for readiness probes. I won't go into the details of readiness probes and aliveness probe, but basically they are responsible to keep your application live and healthy in every state. Okay. So, and then we have configurations such as auto scaling. You can mention the number of minimum replicas that you want to have, and then the number of maximum replicas that that you want to have. These are the replicas of your application. So if the traffic on your application increases and the CPU utilization suddenly spikes, so this Kubernetes controller will automatically create more replicas of your pods, and it will like uh, redistribute the traffic on all the pods that it has created. Okay, so this is something that is very useful in case of you don't have a predictable traffic, and there are certain spikes in the traffic at your organization. So this is pretty useful. You don't have to reserve instances and run your applications on over reserved instances. Okay, so you can set it at like around 80% or 80% of CPU utilization and 80% of memory utilization. So as soon as your application's average utilization goes above 80%, it will create more replicas of your application. And this configuration says that as soon as your configuration average memory utilization goes above 80%, it will create more replicas of this application. So either of this condition hits, it will create more replicas of your application. You can also mention various other metrics also apart from just CPU and memory. In case of Kafka consumers, it can be the lag metrics. In case of your web application, it can be the latency, it can be the throughput. Whatever you feel, you can include. You can make that matrix provide to the HP, and it will auto scale on the basis of that particular matrix. So that configuration you need to provide in the extra matrix configuration. Okay. Then we have the command section. If you haven't provided any command in your Docker file, you can override, or if you want to override your command section that you have provided in the Docker file, this is the place you can execute those commands. So this, if you want to you want to supply this particular section in the deployment template itself, you can do that. Otherwise, it will be picking it from the Docker file itself. Then we have ingresses. So ingresses are like, I will be demonstrating this to you. So I want my application, I want my application to be available at, let's say, demo.devtron.ai. At this particular URL, I want this application to be available for the public to see. So if we check, this application is not available at this particular URL at present because we haven't deployed it yet. So I am just enabling this ingress for this particular application, and then we'll be deploying this going ahead. Then you can give resources for your application. So these are the CPU and memory resources that you can allocate to your application containers. I will be keeping it a little low just to demonstrate you how auto scaling works. So these are, so 0.01 is like 100th of a core. Either you can specify it in form of cores, or you can also specify it in forms of M, which is milli CPUs. So one core is equals to 1000 milli CPUs. So you can do it in either form. This is these both forms are supported in Kubernetes. Okay. So I am giving it in forms of core. 0101. And then if you have some sort of volumes that you want to mount, you can specify what it over here. You have some if you want to create your service as a load balancer, you can specify it over here. In this case, I will be using Ingress, so I will be using the cluster IP. So cluster IP is for all the services that should be accessible within the cluster. Then we have another one, which is load balancer type. And then we have a third one, which is the node port type. Either of these you can provide over here. Okay, so I will be saving this configuration. I will also be enabling the app metrics and saving it. So this configuration is saved. Let me go to the next step, which is the workflows step. So I will be making a workflow for my environment. So for this workflow, I will be creating a CI pipeline. So where this is what where the build will be happening. So I will be doing it from building it from my main branch. And then you can have it automatic or manual. You can select it as automatic or manual. Then you have certain pre-build and post-build stages that you can enable from here. In case of pre-build stages, you can download stuff that your Docker file depends on. You can do that in the pre-build stages. In the post-build stages, you can run some sort of scans. If you want to integrate with a third-party tool, you can also do that over here. So this is all well supported in different as well. So I will be creating this. So I will be scanning my images for the vulnerability. So I have enabled this one. So I have created a CI pipeline. So this is my CI pipeline. And then I will be attaching the CI pipeline to a CD pipeline as well, which is the deployment pipeline where I will be deploying my code. So I will be deploying my code in the dev environment. We give you option to select multiple deployment strategies that are not supported out of the box in Kubernetes as such. So here you can select among rolling, blue-green, canary, and recreate. I will be creating a blue-green deployment. So I'll set it as blue-green. So in the CD pipeline also you have option to sort of define your pre-deployment stage or the post-deployment stage, if you can see here over here. So in the pre-deployment stage, you might want to run some sort of the database migration, then you can do that over here. In the post-deployment, you might want to sort of run some sort of test scripts, you can do that over here. So different supports multiple integrations. So you can configure your workflow in the way you want to. So I will not be creating anyone. So I'll just create this simple deployment without any test cases and all. This is the this is the pipeline that I have just created. So I'll be going ahead and triggering this pipeline. So I'll just quickly see if it is getting my commits. Okay. So I have just switched from the configuration mode to the trigger mode now. So this is the trigger mode. So in trigger mode, I can select commit from where I want to build. I can see which some information about this commit. If you don't see any of these commits, you can force refresh this if you want to do that. But it fetches at regular intervals, so you should be able to see the latest commits. So this is my latest commit that I will be building my image from. So I will just select it and click on start build. So it has started building this particular uh, it has started building image from this particular Docker file that I mentioned. So if you want to see the logs of these, you can check that. You can make it full screen. You can browse through the logs. You can see if there are any errors. You can go back to the Docker file and see rectify those errors. And then if everything goes well, I should be seeing a success on this one. Okay, I got it. Then once my image is built, I am ready to deploy it on my Kubernetes environment. So since this particular pipeline that I created was automatic, so as soon as it finished building the script, it has triggered this pipeline. You can see it is in progressing. So it has triggered this pipeline automatically, as I have set my pipeline to be automatic. So let's see how the deployment is going. I'll go to the app details page, and I can see that 2 pods are up and running. I can check the events of these pods. So these are the events. So you can see that this particular deployment has been created and it has been assigned to this particular node. It has pulled these images, and it has pulled these images that it just pulled. So let me come back to this application. So this is the beauty of Devron, that while you don't have to create any Kubernetes YAMLs or write any Kubernetes YAMLs, you can still view all the Kubernetes YAMLs that it has created. So for this particular application, it has created a replica set. It has created a pod. You can check the manifest of these pods. So these are the Kubernetes YAMLs for these pods. So it also provides a lot of learning opportunities for the developer community. So if you are not very used to Kubernetes deployments and writing Kubernetes YAMLs, or you are not very used to Kubernetes infrastructure and environment, you can learn stuff from this as well. So while deploying your application, you can see what configuration or YAML Devtron has created, and learn stuff as well from here. So if you can see, I mentioned the uh, resources to be 0.01 M. So if I go and see my resources, so it has given 10 M, which is like 1/10 of the core, right? And I mentioned 100 MI, so it has given the resources as 100 MI. This is the Docker image that we just built using the CI pipeline. Okay, so we provide you all the Kubernetes native manifest. You can select any Kubernetes native manifest. For this particular deployment, it has created a pod, it has created a service, then it has created an ingress that I mentioned, then it has created a service monitor as well. So all the Kubernetes native manifests are available for you to see. So if you want to see the auto scaling HP manifest, you can see that over here. All right. So this was for, so our app has been deployed. Let's go back and check on demo.devtron.ai. I should be seeing this application if it has deployed successfully. Perfect. So this was the application that we just deployed. So if you see, the pod name is coming to be GH7VD. So this is one of these pods, right? There are the 2 pods. So one is with GH and another one is with RW. So if I hit this particular URL multiple times, you will see that this particular uh, pod name is changing, because the requests are being distributed among these 2 pods that we have. So Kubernetes automatically balances the load among all the pods that exist for your deployment. So if I hit it one more time, this pod, this request is landed on RW pod. Okay, and then one more time, if I hit it, it has landed on GH7 pod. So Kubernetes balances the load equally among all your pods. So this feature is very helpful for you and when it comes to auto scaling your infrastructure or auto scaling your application. So I'll quickly demonstrate how it happens. So uh, for that, I'll have to pull down this particular threshold. So I gave the CPU threshold as 80%. So it's not going to reach 80%. Let's keep it something around 5% to see if we are able to hit this threshold and then our application auto scales or not. So let me just change this parameter and then deploy it. Okay. So I have already deployed this. So it takes about some time to for the changes to sync up. Okay. So if I refresh, I can see that it's in progressing. The deployment is in progressing. If I see over here, my actual CPU usage was going around 0.05. So these are the monitoring graphs that are integrated within Devtron. So we provide you CPU usage, memory usage, throughput, the 2x6 request that your pods are getting, the 5x6 if your web application is getting any, the latency as well. So these are the monitoring graphs that are integrated within your Devtron UI itself. I'll quickly see if it has created more replicas. Yes. So as soon as I decrease the threshold, if you can see, it has created more replicas of these pods. So now if I go back and hit on this particular URL, application URL, you will see that it has started. Okay. Deployment is still in progressing. Okay. Now is it healthy? Right. It's coming up to be healthy. Okay. Okay, so if now you can see that it is still serving this one from the GH7 VD1, and if I do it again, it is still serving from GH7. So your request can be distributed among the pods in the round robin fashion. So it's going to be right. Now you can see it's shuffling the pods. Right. If you can see, it's shuffling the pods, 𝐸𝐴7. Uh, so it's shuffling among these pods. It's balancing the traffic among these pods, and it's depending on the CPU utilization. So if you see the CPU utilization here, it has increased. The average CPU utilization has increased, and it has created more replicas because of that. So that was about application deployment using Devtron. You can, for some diagnostic, I would like to demonstrate some diagnostic troubleshooting sort of functionalities of Devtron, which has. So you can check the application logs. So if you click on any pod, you have option to check its log. So these are the application logs. You have functionality to be able to grep on these logs. So if I want to grep, I can use this grep option. Then I can even exec inside the container and check if something I have to do. If as a debugging process, if I have to exec inside the container in the running container, I can also do that using this functionality terminal. So I can, let me exec inside this one. Okay, so I have successfully exited inside this one. So if I want to run some sort of commands, I can do that. I can see my application files are present inside the container. So this is also very helpful when you're trying to debug your application. And then we also show you all the events, all the Kubernetes events on the UI itself. And then you also have the option to see the manifest as well. So this was uh, the part of the demo. Then we also skipped something, I guess. That was the deployment build history. So if your app has any sort of security vulnerabilities, which will be shown over here. So this one does not has any vulnerability. So I'll quickly show you an app which has a vulnerability. So this one. So if I check this one, so it shows me all the vulnerabilities this app has. So based on these, you can create rules that you don't want to permit any sort of vulnerabilities, any critical vulnerabilities. So you can do that as well. So that was something about it. So I guess we don't have enough time. So I'll just quickly get back to the slides. So, like I told you, the Devtron project is a totally open source project, and you can contribute to the Devtron project as well. So, recently we started a sort of opportunity for all you DevOps enthusiasts and open source enthusiasts. So you can contribute uh, your chart. So recently we'll be releasing a feature, bring your own chart. So there you can you can create your own Helm chart and integrate it with Devtron. So once we will be releasing that feature, we will be releasing a lot of community charts along with that. So if you have any chart in mind, or if you want to create any chart or contribute any chart, you can directly go to this Devtron GitHub repository, and inside this chart folder, you will find the specifications how you can contribute your chart. And when we will be releasing this feature of bring your own chart, we'll be adding these community charts to those sections along with the proper credits given to your name. So that's about it. I think we are available at Discord for any sort of installation help or any sort of troubleshooting that you're facing with Devtron. You can connect with the Devtron team on Discord. You can find it on the Devtron website as well, which is devtron.ai. I think that should be all. If anyone wants to have any questions, or Adit, do you have any questions from the
Hi,
team?
Prakash. Yeah, we
Yes.
have a few questions for you. So the first question is, can we get the YAML file for our deployment?
Right. In Devtron, if you have created any sort of deployment, so I'll just quickly go back to the demo one. So, sorry, this one, AWS demo. So if you see, we provide you all the configurations right ahead itself. So be it replica set, be it pods, all sort of Kubernetes objects that it creates. It sort of gives you the manifest files for this. This is not a deployment actually. So we use rollout. So in case you want to get the rollout manifest, it's right here. This is not the deployment Kubernetes object. So we use rollout with Devtron because of some enhanced features that we have in rollout. So that's why we use rollout, not the deployment object. So for rollout, yes, you can get the manifest from here. So anything that is created using DevTron, you get the manifest over here.
Okay, thanks a lot. And there was one question about how to contribute to DevTron. Can you elaborate on that? You already explained it, but give a few more insights on that.
Right. So I'll quickly show you. So we have so apart from this particular feature and contribution that I asked for you, so you can contribute charts, or you can even contribute to features on different. So for that, you can go to the issues section. You will see a lot of issues section which are already open. With a lot of issues that are already open. So if you want to volunteer and work on some issue that has not already been picked for by someone, you can you can just uh, contribute to that. So you can connect with the team on that issue, and you can say that you want to volunteer and contribute regarding this issue, and we will be more than happy to have you set up the things for the contribution, and will take it and merge it and release it in the next releases. So if you
Okay.
see Devtron, it's like there are a lot of contributors as well. And these are the users of Devtron. These are the Devtron team contributors as well. So yes, anyone can contribute to Devtron. Just connect with us.
Okay. Yes, you can contribute to Devtron, and if you have any kinds of doubt, you can raise the issue or connect in the Discord server of Devtron. So that would be really helpful for all of you to get started with your open source journey. And if you are already doing that, then it would be a benefit for that. Yeah.
Right.
Thank you so much, Prakash, for the great session. People really loved it, and your demo was great. So thank you so much.
Have a nice day. Goodbye.
Bye. Okay, so the winners for the first quiz are right here on the screen. So first is Bismay Kumar Rana, second is Joshit Gopidi, Karthik Thangela, Sejal Yadav, and Saket. So you can drop a email that we have won this quiz to our email, that is awsusergroup.jaipur.raj@gmail.com, and we will share the further details for that. Okay, and now the next quiz is right here on the screen. The quiz link is already shared in the comments, so you can just start joining in. Use your real name and your full name, because yeah, it would be really helpful if you use your full and real name. Okay. Also, this quiz will be open for like 5 minutes, so you can just start joining the session. Sorry, quiz session. Okay, we have already 126 people in this quiz. We will start in about 30 seconds. So, yeah, start joining in. Okay, we are starting the quiz now. All the best, everyone. You have to be really quick to answer that. It's not just about choosing the right answer, but you have to really quickly click on the correct answer. It's like fastest finger first. Right now, K Karthik is on the top. That's great. Okay. I think most of the people are done with the quiz. So last 1 minute for the quiz, and we will stop after that. I think we can end the quiz now. Or yeah. Okay. We will share the winners after this session, before the next quiz. Yeah, over to you, Aditya.
Yeah, thanks a lot, Siva, for quiz and all. So we are having our next speaker from, I can say, Auth Zero. So Ben is there. So let me add Ben to this stream. Yeah, hi Ben. How are you?
Hey, I'm good, thanks. How are you doing?
Yeah, I'm good.
That's good.
So let me introduce Ben first. So he's experienced technologist with a demonstrated history of team leadership, business development, and community engagement. He's skilled and confident communicator with pre-sales, conference speaking experience, a strong professional with a background in software engineering, solution architect, and business analysis. So it's a bit of I can say some like of the words, but let me tell you, like, he's a very good speaker because I have previously also listened him on other, I can say, sessions. So you will people will be enjoying this particular session. So I think we can start with session. And if you want to introduce yourself again, Ben, then please go ahead, and over to you.
Sure, thanks very much. No pressure at all. Thanks for telling everybody that I'm a great speaker. It means that I've got to really nail it today. One of the things that I want to let you all know about, though, is the kind of presentations I like to give are interactive. So I've got the chat up here. Ask questions throughout. I'm going to try and keep an eye on that. If not, we can cover questions at the end. But please, if there's anything that I'm talking about that you want me to go over in more detail, if you've got any questions that are relevant to what I'm talking about at the time, ask them. We can go through it. My talk itself is probably usually only about half an hour, but we've got 40 minutes, I think, 45 minutes maybe to do it today, which means we've got plenty of time to really get into the nitty-gritty about identity, which is what the talk is about. So as has already been mentioned, my name is Ben Dekrai. I'm a developer advocate for Auth0. Auth0 are essentially like a software as a service platform for identity. So rather than writing your own login and your own password reset and single sign-on and enterprise logins and all of these things, Auth0 is a product in the same way as you wouldn't write your own credit card payment stuff. You would use Stripe or PayPal or some other mechanism. Auth0 is the kind of product that you can use for all of your identity stuff. I noticed the comments are scrolling, so I'm just going to make sure I keep up with it. Yeah, so the talk today is not about Auth0 specifically. Auth0 does deal with identity and authorization and all of those things. But what I want to do today is talk about where we came from, what the problems were that we as an industry, as a computing technology, internet industry faced, and how we dealt with it. So we'll go through that process and we'll see what the new technologies are that we currently use, how the authentication process works in order for you to build applications that may allow you to be sure that you know. And when I say identity, I don't mean like if I log in, you know it's me. In the same way as I could create an account on your current website with an email address that's not actually my name. So when we talk about identity, we're talking about identifying who is logged on based on previous credentials, so the next time they log on, we know it's the same person, whoever that person might be. Okay, let's get into it. So click on my presentation so I can actually do, actually works. So where did identity all start? And this is the first part of the interactiveness. I'd like you to like put a hands up emoji or a +1 or something in the chat if you remember things like Facebook or LinkedIn did it as well, and MySpace and all these different sites. So if you joined a social network, the hard thing about a social network is it's not really, I'm getting a couple of pluses, thank you. Social networks are really useless if you don't have users. So when Facebook first started, I mean, Facebook was predominantly for a couple of universities. But when these social media platforms start, they might have 10 people to start with, or 100 people, or 1,000 people, but they need millions of people to really create this kind of social network. And at the time, other than me telling my friends about it and getting them to come and log in and create an account, and then we try and find each other, Facebook and LinkedIn and all of these social media companies thought, well, what we'll do is we'll make it easier for people to do this. So what they would do is they'd have this friend finder. Facebook called it the friend finder. There were various ones for different systems. And they would say, tell you what, if you give us your email address and then you tell us the password that you use to log into your email, then we can log into your email account for you and we'll have a look at your contact list and we will email all of your contacts and invite them to Facebook. It's a brilliant idea, sort of. And I'm sure a lot of you are already going, oh, cringe. That's terrible. Who even thought of this? And some of you might be thinking, well, that seems reasonable. Why wouldn't you do this? And we'll cover that. One of the things about software development is that we don't all have the time to focus on everything security-wise. So if you're sitting there thinking, you know what, I don't actually know what the issue is, there's nothing wrong with that. You don't necessarily need to know what the issue is, but knowing from this talk what that issue is and how we solved it as an industry will help you understand a bit more about how we're making applications more and more secure every day through these standards. So yes, the mechanism would log in and and get all of your email addresses. So this is roughly how it worked. You have the user on the left hand. Let me use my mouse and make it easier for you to see what I'm looking at. So you've got the user over here, and they've got their credentials. They've got their username and password for logging into their email account. And over here, there's some kind of social network. Let's just say Facebook for now. It could have been many of them. I'm not attacking Facebook. Lots of different systems did it. And the reason they did it was there was not really a better way of doing it. What they would do is say, look, we want you to provide us with your email account credentials, and then, oops, I'm clicking the wrong button here. Go in this direction here. There we go. Provide us with your email account credentials, and then what we'll do is we'll send those credentials to your email account provider. So that could have been Yahoo Mail, or Gmail, or Hotmail, or any of these kind of email providers. We will log in as you. So this isn't using an API or any kind of standard mechanism for third-party systems to talk to each other. They were essentially pretending to be you logging in, insofar as Hotmail or whoever didn't even know that it was a server or an automated script. They were doing screen scraping and injecting information into forms and submitting information so that it looked like a standard user logging in, because there was no mechanism for these systems to talk to each other. And in return, they would then say, okay, well, give us all of the contact details of the person who's just logged in. So they would, in this like scripty virtual way, they would click on the contact menu item in whichever email platform you had, and they would get the list of all the contacts, and they would, that HTML that came down, they would basically grab all of that information, and they would then store it into their own database. And what they would do before doing that, or at some point during that process, is they would want to send an email to all of these friends. So rather than Facebook or LinkedIn or whatever actually sending the email themselves, they would then, again, with this magic scripty pretending to be a human thing, send an email from your account using your email provider. So Hotmail or Yahoo Mail would be sending the email, which, look, this was another clever thing. It's ethically questionable, but this was another clever thing. It meant that they didn't have to deal with all the, because email is a complex, especially when you look at spam protection and all these mechanisms. It's a complex communications protocol. Making sure that an email gets delivered is hard, and Facebook don't want to have that problem, or they didn't want to have that problem. They have it now. So what they would do is they would pretend to be this human, you, and tell Hotmail or Yahoo Mail to send the email on your behalf, which means that your friend gets an email from you, not from Facebook or LinkedIn, but also it came from the Hotmail server, which means deliverability is higher, and the likelihood of it getting caught in spam is lower. So that was a great idea in theory, but it's also a little bit dubious in terms of using Hotmail services or whichever email provider services for this purpose, when it's not even their service. It's like the social media provider is, to a certain extent, possibly misusing those mail services. So there were ethical issues with this, but it was the simplest solution at the time. And then, as I say, they would take all those contacts and they would put into the database. So as well as having emailed all your friends, they've now got your friends' email addresses in the database, so that when the friends then join, they can make that link straight away. On a slight tangent, and this has nothing to do with identity or authentication, another thing that social media providers do is, a lot of them do, I'm not going to accuse all of them of doing it, but a lot of them will do it. You might have heard about shadow accounts or shadow profiles. And Facebook, I'm pretty certain, does this, for example, where if you use this system and my email address got added into Facebook and I never joined Facebook, it would have this shadow dark profile. There's this Ben person. We don't know much about him. He hasn't joined our system, but we know that he's friends with this person over here because that's how they joined in. And over time, they might start building a profile of where I might have been, depending on who else has added me in through their address books. And they now know that these two people might know each other because they both know me. So they would still use this data in interesting and questionable ways. So this was the major issue, this big exclamation mark over here, providing my email account credentials for logging into my email to a third-party system. They can then log into my account and check my contacts, but they can also read all my email, send email as me. They could change my account settings. Potentially, they could even go in and start looking at my billing settings and see the last 4 digits of my credit card. And like, they had full access, and this was a major issue. I was basically providing somebody access as though they were me. So this obviously wasn't ideal, and OAuth OAuth 2.0 specifically. There's another OAuth 1, which is very, very different, and we're not talking about that today at all. You won't see it used very much, if at all, and it has solves a different problem. So OAuth 2.0 is basically an authorization mechanism for authorizing systems to talk to each other. So this is how OAuth works. You make a request from the user makes a request to the social media provider, and I've just realized that the scrolling over here stopped again. I'm going to keep an eye on those contents. The request is made to the service provider to say, hey, I want to add all of my friends. And the service provider says, I need access to your contact list, only your contact list. And the way that I'm going to do that is I'm going to send a redirect request back to you, which then will take you to your email provider. And what you're going to do is you're going to provide your credentials to your email provider. And that's totally fine because they're the credentials for your email provider. This is great. This is a brilliant first start. The social media provider now has no idea what your password is for getting into your email account. Your email provider is then going to generate some kind of token of some sort, and it's going to return that through a redirect back to the server making a request for the information. So this token is actually like an authorization code. It doesn't really have anything inside it that's particular to you. It doesn't have any identity information in it or anything like that. But this token can be then sent from the social media provider directly to the mail provider via a standard API. So we've got APIs in play now. And it says, look, some user that you've just issued this token to wants to give me access to their contact list. And this token will actually have inside it a set of scopes. And the scope, one of the scopes will be access the contact list. So that's the only thing they can do. They can receive that contact list back. They can't send emails. They can't read emails. They can't find out the last 4 digits of my credit card number. This is a very tightly scoped, tightly specified purpose for this token. They can only get the contact details. So now they need to find their own way of doing email. And this is the right way of doing it. They can either sort the problem out themselves, or in the same way as Auth0 is a software as a service provider for identity, there are plenty of options for sending emails through APIs as well. So they can outsource that if they want. Of course, they'll also add it to the database, because why wouldn't you? If you've got this information as a social media provider, that's something they're probably going to do. So that's how OAuth works. The next thing we want to look at, or let's just have just to kind of ground exactly what OAuth is, the permission system. Some examples might be like LinkedIn can read emails on Gmail. You might not want to be able to write emails, but you have these 3 things. The actor can take an action on a target. So that's what authorization is. Another example might be TweetDeck can post tweets on Twitter. TweetDeck wasn't originally owned by Twitter. It now is owned by Twitter, has been for a while, but they are still 2 separate websites. And if you've ever used TweetDeck, it's a great tool for monitoring multiple Twitter accounts. And before Twitter allowed you to do scheduled posts, you could schedule them through TweetDeck and that kind of thing. When you log into TweetDeck, you actually log in with your Twitter account, and there's an OAuth and OpenID. We'll get onto that in a second. There's an identity part to it. But TweetDeck then has permission to take actions on your behalf on Twitter. And Eventbrite is another one. Whenever I've created events in the past on Eventbrite, I've actually connected that to Facebook accounts associated with the events that I'm running. And Eventbrite can get permissions to create an event on Facebook directly. So I don't need to do it in 2 places. I create an event in Eventbrite, I click on push to Facebook, and it sorts all of that out. So these are some kind of examples of authorization. There's not authentication, which is finding out who the user is. Access has asked, can OAuth access your info like Facebook can? So we'll get onto that in just a second. But just to let you know that like Facebook, I'm not sure what you mean by like Facebook can, because when you, let's just go on to the next few slides and maybe it'll answer your question. So here it is. Eventbrite can get Ben's identity from Twitter. This is something that OAuth by itself cannot do, because get Ben's identity is not an action as such. Post on Twitter or read tweets. These are actions that Twitter normally does, but Twitter doesn't provide a get Ben's identity, or it didn't back in the day anyway. So this is where user info comes in. And essentially, user info is a layer that sits on top. It's almost like another API endpoint. It's a layer that sits on top of the OAuth protocol, and it was designed to solve this problem of finding out who the user in another system was. This is basically like the login with Facebook type thing. So once two systems have this authorization permissions between them, one of the actions can be get user info. So let's have a think back to the way that getting contact lists worked. You make a request to some kind of API endpoint, v1/get contacts, for example, and that token that got returned back, you would pass that through as a bearer token. So if you're not familiar with bearer tokens, essentially when you make an HTTP request, whether that's a get or a post or a put or whatever, you've got some headers at the top. And those headers can be things like what content type you're sending or what content type return you will accept. One of those is called authorization. And the authorization header can have multiple different options for the actual value. And one of those is a bearer token, where you put in the word bearer followed by a space, and then the raw value of the token. And then the API that receives this can look at the authorization header, look at the bearer, and validate that token and say, yes, this person has access to get contacts, because that was baked in as one of the scopes in that token. So what get user info does is it creates another endpoint. Now, right at the beginning, when this was first dreamed up, it was basically an inconsistent mechanism across the different providers. So one provider for user info might just be /user info. One might be /user/info. One might be something completely different. One might be versioned. One might not be. And you'd pass in a bearer token again, because obviously you need to prove that you have the scope or the permission to read the user information. But then the response that came back could be anything. If it's is it XML or is it JSON or is it YAML or is it plain text, or like there were no standards around this. Different if you had 2 or 3 already login with Facebook and login with Google, and you want to add login with Twitter, then you might have to read the separate specs and develop a slightly different mechanism for adding another provider for login by using this user info endpoint. So there was no consistency around it, but it was definitely another step forward. It was a consolidation of an idea that, yes, we need to provide some kind of user info endpoint. So what happened was the industry came together and said, hey, we've got like 75 billion different implementations of this user info thing. Let's create one standard, and we'll call it OpenID Connect. Now, in the same way as OAuth 1 and OAuth 2 are very different, there's OpenID and OpenID Connect, also very different. So if you've heard of OpenID, again, we're not going to talk about that today, but OpenID Connect itself is, if you imagine this diagram with a big box, and on it says OAuth 2.0, on top of it is OpenID Connect. OpenID Connect is dependent on OAuth 2.0 because it's that user info extension, but it's a standards compliant mechanism for getting that user info. So what is OpenID Connect? There are paragraphs, and like if you look at the actual spec standard, pages and pages of information, but if you boil it down into the 6 most core parts of what OpenID Connect is, it's basically, like I say, it's a simple identity layer that sits on top of OAuth 2.0. It is used to verify identity. So once I'm logged into Twitter, for example, if I go to the user info endpoint with that token, it's going to verify what Twitter knows about me so that you can do login with Twitter and get that information back. And this goes back to perhaps Aksham's question before about getting identity from Facebook. Login with Facebook would use this simple identity layer on top of OAuth 2 to talk to Facebook and get identity information back. It contains not just the identity in terms of an ID number or something, but it'll actually have basic profile information. Maybe it's got your email address, might have your name, possibly a URL for a profile photo. And it's always an interoperable and REST-like manner. So to make it consistent and easy, SOAP is like a protocol that was used before REST had come in, and we thought, you know what, let's keep it really consistent and modern and up to date. So REST-like manner. And finally, the JSON, the data format that comes back is in JSON. And the beauty of this is that you can have structured data in there. You can have nested information. You can have arrays of information. So it really allows you as a creator of a profile information, if you are the Facebook or the Twitter or the Googles of the world, if you allow people to log in through your site, then you can provide information back in a way that whoever's consuming it is always going to know it's JSON. But the beauty is that you can put whatever you like in there. All right, so how does OpenID Connect work? You can see we've got an extra element in here now. We've got the identity provider down at, where's my mouse? There it is, identity provider down at the bottom. So this could be Auth0, it could be an off-the-shelf product, it could be whatever it is. Don't roll your own. In the same way as you don't roll your own credit card payments, don't roll your own identity and log in. It's like there's so much that goes into it, you don't want to get that wrong. This is your server up here. Somebody's trying to make a request for a resource. And there's a login page that appears from somewhere. Let's see how all these bits tie together. So a user comes along. Oh yeah, one thing I should mention is that your application, before any of this can happen, before you go to production, in order to configure this, the identity provider is going to need to have some configuration or some knowledge about your application. So you'll create some kind of configuration in the identity provider, and this will basically allow, once the flow starts, and we'll see that in a second, it'll allow the identity provider to know what to present to your users. And two key bits of information that you'll get out of here are a client ID and a client secret. And the client in this case, if the open identity provider, if the identity provider rather, down here is the provider, your application is the client. So this is the client relationship we're talking about here, not the client as in your user, but the client as in your web application. So you'll have a client ID, which is this little person face, because it's not like an ID, and a client secret. That's the key. It's a secret. Essentially, this key, or this client secret, is only ever sent back to the identity provider to prove that this client is the one that's authorized to talk to the identity provider about this whole transaction. Without this key, nobody else can talk to the identity provider to make requests for information. All right, let's run through the authentication process, and we'll see how this all ties together. So user comes along and makes a request for some kind of resource from your server. Maybe it's a web page they're trying to get to a dashboard, or maybe they're trying to download a PDF, or maybe they're trying to take an action like make a request to update some information or something. And whereas before they were allowed to see things, but to post, there needs to be some kind of identification of who the user is. So your application is going to say, here, I don't know who you are. We're going to start a login process. And what it'll do is it'll return a redirect request. So this part on the left here is kind of like your browser as well. So it'll send a redirect request to redirect the user to the identity provider. And you can see there that the client ID was passed along in there too. There's a couple of other bits of information there, like scopes. What do you actually want to know about the user? And OpenID would be one of those scopes, because we want to know about the profile. A couple of other scopes. And the identity provider can then use this client ID and say, hey, I know this is John's website. So we're going to ask this user to log into John's website. So we'll use the database of users that are on John's website. Obviously, those users are all in a database that are actually in the identity provider. And we can theme it like John's website, because we know it's John's website because of that client ID. So that's where the client ID comes in useful here. Keep clicking the mouse. Let me just get back to the right place. So we've got this one here. So the next thing it's going to do is going to return that login page, which is themed exactly the way. So the user now sees a login page generated by the identity provider, not your website. So this is great because you don't need to worry about any of this. This communication flow over here between these two servers can be secured by the identity provider. It's a very secure way of doing that. And the credentials are then sent back to the identity provider. Again, you don't need to worry about storing passwords and hashing algorithms and password resets and all of these kind of things. And then if you notice just in here, once you've logged in, the identity provider is going to convert that into some kind of user. It says, okay, well, we know that Ben's just logged in. And we're going to send this, we're going to generate this authorization code, which is a random string. It has nothing to do with me at all. There's no representation of me in there. If you looked at it, you would not be able to convert it into anything that represents me. It's just totally random data. And that totally random data gets returned back to your web server via another redirect. So if we just look at the flow so far, I've made a request to your website. Your website says, here, I'm going to redirect you to the login server. Login server gives me a login page. I provide my credentials to the login server. The login server then redirects me back to your web application. And your web application now has this authorization code. Doesn't say anything about me, though. But what I can do is I can take this authorization code and the client secret, and you can send that to the identity provider directly. So we know that on this side here, this is a server-to-server connection. It's over HTTPS, so it's secure. Over here, we've got a browser. In the browser, we could have a cross-site scripting attack. We could have malicious browser add-ons. We don't know what's happening in there, which is why we don't pass tokens back through the browser, because they could be intercepted. But what we can do over here is we can send this auth code and the client ID, and we're basically, your application's going to the identity provider and saying, I've just been given this access code, this authorization code, which you just generated for somebody. Can you tell me more about that person? And the identity provider says, well, I know this authorization code matches Ben because he's just logged in. So I'm going to create some tokens and I'm going to return them back to your application. So your application has now received an identity token about me from the identity provider based on my login. Those tokens are JSON Web Tokens. And this is what a JSON Web Token looks like. Does that make sense? All right, let's move on. No, let's dive into this a little more. So if you haven't seen an access token before, it might look a little bit overwhelming, but essentially it's base64 URL encoded data. Let's just color code it a little so we can see what's going on. We've got a header, that's the red part, and then in the purpley color, the middle bit, that's the payload. This is the data about me, and then the third part is the signature. And you can see the two highlighted full stops there. Those are what are used to separate it. So when an access token or an ID token or any kind of JSON Web Token comes in, we can split it on those dots. And there are other formats of JSON Web Tokens as well. You can get 5-part tokens and 3-part tokens. But for the most part, when you're dealing with this, and you won't need to worry about this when you're using an SDK to implement JSON Web Token based authentication, it all comes out of the box. So you don't need to worry about that. But it's useful to understand under the hood what's happening. So we've got a header, the payload, and the footer. The header, if we break it down, if we base64 URL encode it, it's basically JSON. And we format it slightly nicer so that our brains can read it. We can see that there's an algorithm and a type. There's a couple of other things in there as well. The type is JSON Web Token because there can be multiple different types of token. There are plans possibly to add in the same ways you can have content types that have pluses in them, application or slashes, even like application /JSON. You might be able to have a JWT/identity or JWT plus access or something, just so that we've got a better idea of what the purpose of the token is. But you don't need to worry about this right now. Essentially, we can just confirm here that the type of token is just a standard JSON Web Token. The algorithm is an important part. In this case, we're using an HS256 or a HMAC SHA-256 hashing algorithm. You don't need to know about hashing algorithms or any of this lot, but just know that to generate the signature for verifying this, we'll need to know that bit of information. And then the bottom part is the identity part, the payload. So you can see SUB. This is a very common standard key value in the payload for a JSON Web Token, and it stands for subject. So remember before when we saw in the diagram that you had your application and the username and password was stored in the identity provider? Your application is still going to have a database of whatever it is you're providing access to for your users. And there'll still need to be a user model or a user table in that database. But instead of having username and password in there, you'll just have a subject. So now every time I log into your web application, you're always going to get this same subject. This value here will come through. Even if I change my username or my email address, or I log in from a different computer, or anything changes, that subject never changes. That's your unique ID of who has just logged in. So you can now create a record in your user database saying, okay, create a record with this subject, and here's some information about him or her that we want to remember. Now you've got name and job title and region. These are kind of, because it's JSON, you can put whatever you want in. And then there are some other standard types at the bottom. IAT, issued at, EXP, expired. So there's extra bits of information that come out from there. And here's where the signature comes in useful. So this screen is getting a little bit busy, but let's have a look what's going on here. So this part here is what we just saw on the previous screen. So this is the header and the payload. And essentially what we're doing is we're taking HMAC shaft 256, which is the hashing algorithm, to create a signature. And this hashing algorithm requires a password or a pre-shared key of some sort. And the result of that is then base64 URL encoded and put into this value called signature. And now if we assert the signature we just generated is the same as the signature that came through in the JSON Web Token, then we know that the JSON Web Token hasn't been tampered with. And again, you don't need to worry about the implementation of this. This will come out in the SDKs that you're using for whichever platform your identity provider you're using. But it's useful to know that this JSON Web Token, once you've received it, your application can verify that it hasn't been modified since the issuer created it without having to ask the issuer. This is actually a really key point. If you are familiar at all with tokens for like API keys for talking to servers, the API is going to have to make a request to the issuer saying, hey, is this key valid? But as soon as you use a JSON Web Token, they don't need to do that anymore. Yes, JSON Web Tokens are a little bigger, and they take slightly more processing power to verify than just a string, but they take away the whole need to have your application talk to Auth0 or whoever and saying, hey, is this token valid? You can prove it yourself. It's great. So some other things that you can get are access tokens. So we looked at the ID token just now. Here's an example of an access token. And like I said before, they're often 3 characters. They're a whole lot of standard, and they're not enforced. Like you could use ISS for something else, but it's highly recommended that you don't because you'll confuse somebody. But there are a whole lot of standard suggested key value pairs. ISS is the issuer who created this token. SUB is a subject, who was it created for, who's the person who's logged in. AUD is the audience. This is a really useful one for APIs. The API is the audience. And now the API receiving the access token can say, was this token generated for me? If I'm not api.example.com, then I ignore this token because it wasn't generated for me. AZP is I can never remember what it stands for, but essentially that's the client ID. So I now know which application you logged into. You've got the issued at, you've got the expired, and here's where the scopes come in useful as well. Maybe the scope of this access token is only to post an article. You can't delete articles, but you can post an article. Karthik's asked, all these web tokens are 256-bit encrypted. So they're not encrypted. They are base64 URL encoded, and this is very important. The payload information that comes through, anyone can read. When it looks like a JSON Web Token, brains can't read them, most brains. If you can base64 URL decode in your head, then you could read a JSON Web Token. Anybody can read a JSON Web Token. So they're not encrypted. What they have done, though, is the third part is a signature. So it's taken the header and the payload, and it's created a signature so you can verify that later that the payload has not been tampered or modified. So the title of the talk is To Identity and Beyond, and where is beyond? So this has kind of brought you up to where we are with OpenID Connect and OAuth 2.0, how it all works and ties together for identity. And as you can see, there is so much going on under the hood, but by using an OpenID Connect compliant or compliant, the other word's gone out of my brain, provider for identity, you don't need to worry about all of that. That all happens under the hood. But you can see there's so much going on within standard authentication that I keep going back to the payments example. You wouldn't want to roll your own. So where is beyond? Well, this is a slightly more complex version of what we were looking at before. But let's have a look what's going on here. We've got our identity provider over here, and we've got our user. And our user might be logging in via a web application or via a mobile phone. And the mobile phone might need to talk to an API. And then you've got your web application server over here that talks to a database. And over here, maybe you've got an Active Directory because your internal employees want to be able to log in as well. And one of the advantages of all of this, OpenID Connect and OAuth, is that you can have these tokens that get passed around. And remember how I said that the tokens are self-verifiable through that signature? That token, when it gets passed back to the web application server, for example, can then be passed straight onto a database layer, and the database can verify that the token is valid before responding. The API can also receive that token directly from the server, or even via this request here from the mobile phone. Mobile phone, for the orange lines, these are the login lines. The mobile phone and the web application only ever provide credentials to the OpenID compliant server. But the token, the mechanism of using JSON Web Tokens, it really makes it powerful in terms of conveying this identity. And when you're looking at access tokens as well, the authorization permissions between these applications, and even though it looks complicated, it simplifies development so much. So I hope that that's been easy to follow. I've tried to take my time. I've tried to keep an eye on the questions as well. I see there's a question from Aniket about compliance with MD5 or SHA. So there are a number of different hashing algorithms. SHA or HMAC, SHA-256 is one of them. You've also got HMAC SHA-384 and 512, and they're all. And I don't want to go too much in depth on this. Feel free to hit me up. My Twitter handles on the slide if you want to know more about this. But you've got symmetric hashing algorithms where every actor in the system, all the web applications and the identity provider have to have this one shared password. And then you've got asymmetric or public-private key signing, such as RSA SHA-256 and RSA SHA-384 and 512. So those are just 6 of the different hashing algorithms. There are about 15 in total that you can use. But yeah, so they're basically creating the signature that allows any system to verify, or any permitted system to verify, that the token hasn't been tampered with.
Yeah, I think there are no more questions.
Excellent. Bring them on.
Yeah. Thanks a lot. Like, people are loving the session, and the way you explained, it's so awesome for them. So thanks a lot, Ben, for joining us.
You're welcome.
Thanks a lot for session. We are having the quiz now, so I think we can go ahead with the quiz. And yeah, so Vineet, can you share the screen for the quiz? Yeah, let me add it. Yeah, so we have the quiz now, and everyone can join the quiz. We are dropping the link for the quiz in the description. Once we'll post the link, you can join that. Yeah, so link is in description. So please join the quiz and let's start the quiz. And
I'm going to take the quiz as well. See if I can get it wrong. Ooh, 96 other players. Can we make 100? 97, 98, 99. Oi, 100.
yeah, people are actually loving this quiz, and also, yeah, we can start it. I think we can start it now.
Oh, up to 105. Some last minute joiners. Good luck, everyone.
Yeah, so let's start the quiz. All the best to everyone. We will be showing only the top 5, so yeah, that will be. there. There is some tough competition. I can check. Some are going up, some are going down. Yeah, I think we can end the quiz. There are lots of people who are just completed, and yeah, so it's done. Thanks a lot, Ben, for joining in and the great session. We will
You're
take
welcome.
you
Thanks for having
over.
me.
Yeah,
Congratulations
thanks
to
a
the
lot.
3 people for getting full score on this one. It's amazing. I
Yeah,
got
yeah.
70%.
Yeah, people are there and they are just participating. Yeah, so we have the previous quiz winner also with us, so you can check the names in screen. So there was a quiz before the session, and we are having the names on the screen. So if you any one of you win that, and so you can just ping us on mail. So we'll drop our mail ID. Just ping us on mail, and we will reach out to you for sure. Yeah, thanks a lot, Ben, for joining in. Have a great day.
Thanks for having me. Thanks, everyone. Have a great
Yeah.
day.
Yep. Yeah, over to you, Seema, for the next session with Pratik sir. Let me go.
Yeah. Thank you, Aditya, and thank you, Ben. Hi, Pratik. Let me introduce you to the audience. Okay. So I know you all know him by his profile. I definitely know this. Okay. So Pratik is a popular programming instructor and an A software engineer currently working as with Google as an SDE 3 and founded Coding Minutes to bring affordable quality coding courses on Udemy. He is known for his amazingly simplified explanation that make everyone fall in love with programming. He has over 5 years of experience in teaching and has trained 50,000 students. That's a lot. His interactive resume on pratiknarang.com is quite popular. You definitely should check that out. It's pretty amazing. You can get lots of insights how you can modify yours. In the past, he has won many national level hackathons and been to ACM, ICPC, and worked with SanDisk too. Hello, Pratik. How are you?
Hi everyone. Thanks for the warm welcome and inviting me for this talk. Um, yeah.
We are glad to have you here.
So I know it's a tricky topic. Generally, people say competitive programming versus software development. I have been invited to speak for competitive programming and software development. Okay, so I have to justify both, and that's why I am here. So it would be a short session. I will not take a lot of your time, but if you have any comments, any questions, you can reach me out in the comments. I'm just going through them as well. Hi, Sriniket. So it's a topic that a lot of people get confused during the college, whether to go into Android, web, or competitive. So we will try to clear out some confusion today about some myths about competitive and software development. Okay, so you already had my introduction. I am currently SD3 at Google Hyderabad, and I created codingminutes.com, where you can find a lot of pocket-friendly, affordable programming courses which are hosted on Udemy. And yeah, so that's what I'm working on for the last few months. And in 2-3 days, I'm bringing a very amazing course on data structures for beginners and intermediate programmers. My last course, which I launched about 2 months back, got a huge response from 100 plus countries. And I'm sure a lot of you might have also joined that particular course as well. So yeah, that's a little bit about me, and more or less yeah. So for today's agenda, I will be talking about what is competitive programming, where it is used in software development, what should a college student do? Should he do competitive programming throughout all the 4 years, or should he do development as well? And what are the current hiring trends, how they are changing? Okay. So let me start with the fact that programming is a skill, and all of you want to master that particular skill, and this skill has different levels. Okay, so competitive programming generally, some people confuse it with basic data structures algorithms. Some people confuse it with simply solving problems on online platforms like CodeChef, Codeforces. So basically, in my opinion, I rate this competitive programming as an extreme level of programming. It is also known as sport programming, where people compete with each other and they write optimized algorithms so that they are able to get the same results in a lesser time complexity using a lesser memory as well. So basically, I say, okay, if you're learning the programming fundamentals such as loops, functions, arrays, you are on the level 1, where we are talking about the basics of programming. That I don't call it as a competitive programming. The next level is like you are first you learn the basic components of programming. Okay, the next level is you have learned how to drive a bicycle. Next level is you need to learn how to drive a bike. So this is where the software development category falls in. Okay, so in general real life, what do you need to do? So most people would need to learn a bike or a scooter or a Activa or a car to drive on the road. But there would be very few people who would also learn that skill for a F1 race. Maybe driving a car in a F1 race is a whole together different skill. It requires a lot of effort to learn how to drive an F1 race. Okay, so this is what competitive programming is. This is about competing with other people. This is about building the most optimized algorithms. But this, do you think, is this driving in a F1 race skill is useful in real life? Not a lot. Okay, it can make you a good driver on the road, but you might not be using those advanced algorithms, optimization techniques in solving your day-to-day life problems. Okay, so for most of you, I would recommend that you learn the basics, you learn the data structures, you learn the algorithms, and you reach this second category. Okay, for this one, those who are passionate about, those who are actually want to compete and Yeah, so people are saying I like Prateek's interactive resume. So yeah, thank you. So competitive programming takes these algorithmic skills to the whole new level, and there are a lot of algorithms you may not use in your daily life, but learning those algorithms will definitely make you a good programmer as well. Okay, so that's about competitive programming. So I found these pictures on my Instagram, so just thought to stitch them together so that I could make this meme or example to explain you the difference. Okay, so this third category, I would say it's like the competitive programming category. So I hope I'm making sense. And yeah, okay, so this is level 1, this is level 2, and this is level 3. Okay, so this is CP. Okay, so that's what I was trying to tell you. Okay, I have a question for you. All software applications have one thing in common. So who will tell me what are the things, what is one thing that binds together all software applications? Let's talk about Zomato or Uber or Swiggy or Facebook or any other application. What do you think? What is one thing that binds together all these applications? Who will tell me? Come on. I want your answer to this question. Tell me the one thing that is common in all software applications. That's great. People are saying data and data structures. Yes. So all software applications have one thing in common. They work on data. Okay. Talk about any software application. It is doing some kind of processing of data. Okay. So I will give you few examples. And in order to store that data, in order to work on that particular data, you need some underlying storage as well. Okay, so data needs storage, and storage again is of two types. One is the storage that is there in the RAM, okay, and one is a storage that is there in the disk. Okay, so for disk we have databases, and for RAM we have what? In order to store the data in the RAM, we have data structures. Okay, and even these databases are inspired from the concept of data structures. You might have heard about B plus trees. Okay, so they are used in creating databases. You might have heard about graph algorithms. So graph is a data structure, and there are also databases which are inspired from the concept of graphs as well. Okay, so all this data that you're storing either in the disk or in the RAM, it is stored in data structures or in databases. Okay, so RAM has limited memory. Okay, it only stores the data that is currently required for the processing, but disk is like a SSD or a hard disk. Okay, that stores all the data that so this data will persist permanently. Okay, so this data is persisting permanently in the data centers, and RAM data is persisting for a shorter duration. Maybe the fresh data is in the RAM after it has been processed and it has been moved to SSD. Okay, so the data goes from RAM into SSD, and it comes from disk into RAM as well. So it all depends upon the application logic, which data to keep in RAM, which data to keep in disk. And sometimes we also have a memory which is known as cache. So cache is a highly optimized memory that is used that may also have some application specific logic, what data will persist in cache. Okay, so yes, we have databases like SQL, MongoDB. There are SQL based databases. There are no SQL databases. There are graph databases. Okay, so every application is going to work around data. Okay, so also even my recent experience at Google, I've been working on these kind of applications, and one problem that I was solving, that was basically that we had huge amounts of data, and we have to do some kind of a string searching in them. Okay, maybe we have to search for emails of maybe 10K users in a large, let's say, large number of text reports. Okay, so generally, most of the times you would find very common data structures like list, array, or map. They would solve your purpose, but specifically for this particular application, we have to come up with a design that optimizes the queries for large number of users. Okay, so at that particular point of time, we have to create a specific trie-based data structure. So trie, if you know, is a prefix tree kind of a data structure, and we have to optimize this problem using a prefix tree. Okay, so generally you won't encounter hard data structure based problems regularly, but sometimes while working on a system design or solving a problem using a system design, you may need to think of a optimized data structure that can reduce the load on the server, that can reduce the processing time, that can reduce the complexity. So knowing these data structure actually helps in the software development, and every system design problem that you're going to solve, this system design involves a hidden data structure problem as well. Okay, so every system design problem has a hidden data structure problem. For example, you want to build a system to process the videos that are uploaded by the users on the YouTube. Okay, so you need a processing pipeline that will involve the use of data structure like queues. Maybe multiple people are uploading their videos, and each video is going to take certain time to get processed. So what you're going to do, you're going to put those videos inside a queue, and then someone is going to pick those videos from the queue. It will go to the processing system, and maybe the video is processed, and that then it is stored in the database. Okay, so you need certain kind of data structures at your server which can persist the information while it is being processed. Okay, so every system design problem is going to involve some hidden use of data structures. Even if you're making a game like, let's say, a simple zero cross game, okay, maybe tic-tac-toe. So what data structure you will need? Who will tell me what data structure you will need to make this kind of a game? Okay, so simply you will need a 2D array. Okay, 2D array is a data structure. Okay, 2D array is a data structure. Or maybe you're working with images in machine learning. Let's talk about machine learning. You're going to process, let's say, a lot of images. So each image is nothing but it's a 3D matrix of pixels. Okay, so if you have an image of, let's say, 1080 by 720, and each pixel is represented using three values, let's say R, G, and B, maybe 255, 200, and 80. So you actually need a 3D array data structure to store one image inside the RAM. Okay, that is something that we do very frequently. And sometimes this data can be in the form of a video. So a video is nothing but it's a list of images. Okay, so if it is a list of images, then each image, as I said, is a 3D array. Then list is adding one more dimension. So this data can be a 4D data. Okay, so a sequence of frames. So we have a 4D data. The fourth dimension is the dimension of time. Okay, so we will need a 4-dimensional data structure, a 4-dimensional array to store this data. Okay, yes, so red, green, and blue. So RGB colors it's a RGB matrix. You can actually see in the code itself. If you are familiar with Python or you're working with a library, there is a library known as NumPy. There is a library OpenCV. You can actually read any image and see the underlying array behind that particular image. Okay, so data structures play a very important role in system design, in designing applications. Okay, so let's talk about an application like Zomato. Then maybe I tell the app, actually I want to find all the orders. Maybe I want to find all the items that are offered by a restaurant XYZ. Okay, or let's say I want to find out all the pizzas that are offered by Domino's. Okay, so one thing is Zomato is going to maintain a list of restaurants R1, R2, R3, R4, R5, and so on. Okay, and each restaurant has multiple items. Now suppose if I want to find out what are the items offered by this particular restaurant, so what I'm going to do, what kind of data structure might be useful? Okay, so instead of keeping it as a simple array, we can actually maybe use a hash map. We can say, okay, I want to find out what is offered by RX, this restaurant. So we can put all these values as items that are offered by this particular restaurant. Okay, so a simple data structure like hash map could be useful in this particular case. Okay, so knowing what data structures, what operations we can perform on different data structures will help you to decide your application logic, and that is going to optimize your app as well. Okay, so if you return. If your app is fast, then you're going to have a good user experience as well, because people don't want to wait for their orders. People don't want the page to be loading. Okay, so we want to give good user experience, and the backend for building a good user experience requires extensive use of data structures. Okay. Yes, indexing will also be able to help. So yeah, so maybe you want to build an application like Uber, then storing this data may require a different kind of a data structure. Okay, now the problem is not about finding, let's say we have lots of cabs on Uber, let's say from C1 to C1 million, we have lots of cabs, and maybe a user is standing here. Then how do you find out what are the nearest cabs that are available to this particular user? Again, this can be a data structure problem. You will need to find out what all cabs are available, what cabs are available in this region, and what cabs are available to this particular user. So again, we have to think and come up with an algorithm which computes it in a very fast time. Okay, or maybe you want to find a route. Maybe the cab is a shared ride, and maybe you want to find out what co-passengers should I pick so that the time of the trip is reduced. Okay, if it is a shared ride, from what locations should I pick the co-passengers so that the time of the trip is reduced? Again, it would be a problem that can be solved by the knowledge of competitive programming and data structures, and you have to come up with a design to solve this kind of a problem. Okay, so there might not be a straightforward algorithm, there might not be the best algorithm, but maybe you can come up with an approximate algorithm that gives you close to the best results. Okay, so yeah, so that's another application. Okay, even in machine learning applications like computer vision and all. Okay, so there is a concept of image segmentation. Okay, nowadays this image segmentation is done using deep neural networks, which are based upon CNNs. But earlier, if you go back few years, the image segmentation was done using graph algorithms. So I will give you one example. So earlier, this image segmentation, maybe let's say there is a cat in the picture and you want to identify what pixels of this picture belong to the cat. Okay, so segmentation is nothing but it's a pixel wise labeling of pixel wise labeling or classifications. Okay, so earlier this problem was solved using graph algorithms, and in graph algorithms you might have heard about a topic which is known as network flow. Has anyone heard about network flow, min cut, max cut? Has anyone heard about this topic? Network flow, min cut, max cut. So I have a graphs course on Udemy that talks about this topic, and this topic was used to build a real life application of segmenting what pixels belong to what object. Okay, so you can see again it's a topic that generally people don't study in data structures, but it is something that I teach in competitive programming. Okay, so so if you understand graph algorithms in depth, you might be that might help you in future if you go into ML side of things or deep learning side of things. And although nowadays this is solved using deep learning, so these are old algorithms, but yeah, they are still used in certain applications. Okay, so the problem with deep learning is they require a lot of data, but if you don't have a large data, then you have to come up with techniques like these. Okay, so yes. Okay, so now through these lot of examples, what we have observed is that problems involving data will require how the data is stored, and depending upon how the data is stored, we perform different operations on the data. Okay, so we create new data, we read data, we update the old data, and we also delete the data. Okay, so these are operations are known as CRUD operations, and every application will involve doing these CRUD operations. Some some applications may be read intensive. Maybe you are reading a lot of data. Some applications might be write intensive. That means you are writing a lot of data. Okay. So for example, let's talk about YouTube. Okay, so maybe 1% of the people are creating videos, 99% of the people are watching videos. So that means a lot of reads are happening as compared to the number of writes. So accordingly, your data structure should be optimized to support these 99% of the people. Okay, we don't want a data structure which optimizes for writes. We want to optimize the reads. Okay. Yes. So all web applications will involve these CRUD operations as well. Okay. So depending upon the application, the data may be in the form of an array, it may be in the form of a hash map, it may be in the form of a priority queue. Let's say nowadays we know that COVID-19 drive is going on, and maybe out of 10 million people, we want to prioritize the 1 million people. We want the software to come up with the 1 million people who are maybe in the highest age group, and we want to give them the shots first. Okay, so in that case, an application like priority queue may help because it solves this problem in an optimized time. We do not need to sort the entire list of people. We can build a heap and find out the top million people from that as well. Okay. Okay, and we talked about graphs. So graphs are also used in databases, as I said. One example of graph database is a Neo4j, and applications like Facebook, Twitter, they need these kind of graph data structures to optimize their queries. Maybe I want to find friends which are people who are connected with me and they are interested in watching these kinds of movies. Okay, so you will not run a query on a billion people. You will run only query the people who are maybe connected with me. Okay, 1 degree, the first degree connections. Okay, so this is another area where these data structures might be used. Okay, so what is the advice I would like to give it to you is, do understand the basics of data structures really very well. They will help you in becoming a good software developer. Regarding competitive programming, whether you want to go into the advanced data structures or solve problems on code forces or not, I would totally leave it to you. Okay, so if you are interested, if you're passionate about solving those kinds of problems, then you can do competitive programming, but it is optional. Okay, but overall it is a good brain exercise. It is a rewarding experience. It will definitely help you in coding interviews. It is good for college students and learners. Once you're into the industry, you don't need to spend time into these competitive programming problems, because you would have the own problems of your own on your own. Okay, and taking part in contests gives you sense of achievement. Okay, people write in the resume that I won 10th rank in this particular contest, and even companies see that, okay, what you have achieved in Google Kickstart, what you have achieved on code forces. Okay, and then it also helps in online hiring rounds. If you see, a lot of companies are asking questions on competitive programming. So if you want to practice for those rounds, then definitely do some coding contests and learn advanced topics which sometimes may or may not be useful. So as I said, it's like driving a car in the F1 race. That car might not be used in your real life. So similar is with the competitive programming. It will help you to clear the online rounds, but it might not help you with the real software development that you generally do. So software development is more real. You build the real software for the real users, and it is good for society. People get to use, people can use a lot of applications, and you can solve real life problems. Okay, and there is also a steep learning curve. Once you enter this software industry, there are lots of frameworks, lots of new technologies that are coming in, emerging in, and you get to learn a lot, and you get to solve new and challenging problems every day. You have to come up with the designs of new systems as you progress through your career, and a lot of things you can do in software development as well. Okay, so for college, I would recommend, maybe for a couple of months, maybe 6 to 8 months, definitely do data structures and algorithms really very well. If you're interested into CP, go into that. Otherwise, some amount of web development or Android or some other stack you should also do at least for 3 to 6 months to get a hang of real software development. And this is something that is going to help you to build projects for your resume. And this is something that companies nowadays are also appreciating. Okay, hiring is moving from competitive towards web as well. Okay, so ideally you should have both these skills in your resume. Okay, so do both. You can do 60% on competitive, 40% on dev, or you can do 40% on CP and 60% on dev. So this is something that I would recommend. Ideally 50-50 is recommended. Okay, and you should manage your college time accordingly. कि second year में तो ठीक है data success algorithms, third year में तो little bit of web development, or if you're starting from the first year, then you get an edge because you have lot of time to master these skills. Okay, so generally 12 to 16 months is good enough time to master both of these skills. And apart from it, you have a lot of other semesters as well in which you can learn about new topics like certain frameworks like Android or machine learning or data science or working with version control. So a lot of things you can achieve in your college if you start from your first semester itself. Okay, so that's all about my talk for today. I'm getting some questions. I'm in the 10th grade. I want to get into MIT, have a good score, and provide. So yes, Samarth, do prepare for the Olympiads. It's going to be really helpful, and very less people start during their college time. And if need arises, you can take some of my just give me a minute. I will show it to you. So I'm creating these courses. If you're preparing for Olympiads, then doing this competitive and level up course will also help you. Okay, so all these courses are there on my website codingminutes.com, and all of these courses cost less than a pizza. You can pick any course of your choice, you can do it, and that's also going to help you. So I'm bringing a course on competitive programming for those who are interested. Web development will also come, but yeah. Okay, so people are asking me for the mail ID. So my mail ID is prateek@codingminutes.com. Okay, and you can also connect with me on LinkedIn, and I also have a Gmail ID which is prateeknarang111@gmail.com. Okay, so that was about the topics that I wanted to touch today. I hope you gained some knowledge, some insights about competitive programming and software development. So in real, you have to do both. Once you graduate, you would be focused on software development, but during your college, you should also focus on competitive programming because that is something that is going to help you with interviews and becoming a good programmer as well.
Thank you so much, Prateek, for the wonderful session.
All right. Thank you, everyone. Bye-bye, and have a nice day.
Bye.
Bye.
Okay, so the next quiz is up. You can join this link. And yeah, wait. Quiz link is also shared on the chat. You can start joining. We will wait for 30 seconds for you to join, and then we will start the quiz. I think we can start the quiz now. Yeah. All the best, everyone. Be fast and right about the answers. Akash is leading the leaderboard. Okay. Following up with Aryan. That's great. Okay. Okay, Aryan is at the top right now. Let's see if one can top him. Yes, Akash topped the leaderboard. Okay, following up with Aryan. Quiz is still on. Okay, all of them have all the correct answers. That's really great to know. Akash, Dushyant, Amit, Adhar, Parth. That's great. Okay. I think we can end the quiz now. Yeah. Okay. You are on mute, Aditya.
Sorry, Shiva. So I was saying like we completed the sessions before the time.
Yes.
Yeah, that's a great thing. And thanks to Pratik sir, they completed so early.
Yeah.
Yeah. Yeah, so I think we have the 5 winners on the scoreboard for the ban. Yeah, for the ban one quiz. So there was a quiz before this particular quiz. So you can check the, I think, the scoreboard for it. Okay, so whoever the winner, just ping us on our mail ID. We will get back to you for further details, what we need and how to process. And I think we are good to go. So,
Also, we
so
will share the winners of each and every quiz on our socials. So take a look at
yeah,
that. And
If
then
you are
email.
confused, then yeah, please check on the socials, then check the mails, right, Shiva?
Yes.
Exactly. And I think we didn't left anything for today, so let's sum it up.
Yeah. That was a great day.
Yeah. So
It was.
whoever joined, there will be lots of contests will be there, and Agora contest will be there tomorrow, not today. Okay, so you can join it tomorrow itself. It's not today, and tomorrow we'll be starting at 12 p.m. itself. Okay, so you all are welcome, and I
Okay.
think we can drop now. What you say, Siva?
Yeah, sure. Thank you
Yeah.
everyone for joining in and have a lovely day.
Okay. Bye bye.
Bye.